Good afternoon and welcome back to day 2 of the Global Additive Manufacturing Summit 2020. It is so good to see all of you here today. We will be kicking off our summit very soon, and so get yourself comfortable and ready for an enriching day ahead. Yesterday, we had 6 amazing thought leaders and engaging moderators who shared the capabilities of AM in enabling sustainability, with examples and use cases of AM in various industries such as metal production, fashion, and food. We also explored how we can ensure sustainable practices in the additive manufacturing industry as well. Today, our focus will be on future casting and will be on emerging applications that could be game changers and have an impact in those industries where they reside. The summit today will feature 2 sessions, with the first one exploring utilizing AM to boost the space tech industry, and the second one diving into novel uses of AM in the food industry. So, before we officially begin with our session on emerging applications, I'd like to warmly welcome our session chair, Mr. Aditya Chandavarkar, who is dialing in from Mumbai, India. Aditya is the co-founder of Indian 3D Printing Network, which is a knowledge sharing and business networking platform for the AM industry in India. As a part of the Indian 3D Printing Network, he constantly engages with the Indian and global AM community to jointly develop initiatives to catalyze the growth of additive manufacturing. With his frequent involvement in the community and his AM Chronicle platform, here is Aditya to helm the emerging application session. Namaskar, Aditya. How are you doing? All good in Mumbai, and I think business is thriving. So tell us a little bit about it before you take over the session.
Yeah, Namaskar, Mahendran. Great to be here as a part of the virtual AM Summit. Would have been loved to be there in person, but this is the way we are doing things now. So, and I must say we are evolving with the pandemic here in Mumbai. It's a challenge, but I think we have to evolve and survive as we go ahead. And the Indian AM industry has been growing in a slow and steady manner from the past 5 to 6 years, and many interesting applications have come to forefront in the recent times. And in line with the theme of our first session today, I think with the space industry, I think both the government agencies and private companies here have been adopting AM in a very steady manner. So I think, and for our first session on emerging applications, I think it's going to be quite an interesting one, where we'll be focused on the applications of AM in space. And space is always exciting for everyone, right? It's the unknown, it's the great opportunity, the endless nature of it. Space is always something which excites us. So it's great to have this speaker panel today, which brings together diverse expertise from organizations ranging from a thought leadership company building the space ecosystem in Singapore, an innovative company using 3D printing to build housing structures, and a space tech startup developing launch vehicles. So I think it's going to be a very nice composition of topics. And before we move on to the sessions, let me invite all attendees to leave your questions in the question and answer panel on the right side of your screen. And you can leave them at any point in time as we hear from our speakers. And these questions will be answered live in the panel discussion right after this. So taking the lead today, we have Jonathan Hung, the Executive Chairman of Singapore Space and Technology Limited, also known as SSTL. SSTL is Singapore's leading organization focused on developing the space tech industry through industry meets, its own accelerator programs, and space tech training. Jonathan today will be speaking on the SpaceX influence, the ticket to space. Following Jonathan, we have the founder and CEO of Appetit, Anna Cheniuntai. I think Anna is a visionary in herself, and Anna leads a construction company that employs additive manufacturing to build homes. The company seeks to make housing affordable, and they were a finalist at NASA's 3D Printed Habitat Challenge in 2018, demonstrating that construction AM extends beyond Earth as well. So we'll be soon hearing from Anna on the next revolution, construction 3D printing on Earth and beyond. And last but not least, we have Adam Gilmour, the CEO and founder of Gilmour Space. Adam has always been passionate about space and has set up Gilmour Space to provide affordable, reliable, and dedicated launches into low Earth orbits in order to make space more accessible. And in line with his goals, Adam will be sharing on exploring the new frontier in space, technologies, and business. So if you're ready, take it away, Jonathan.
Hello, everyone. Jonathan here from the Singapore Space and Technology Limited. We are Singapore's primary space organization that helps to coordinate various space activities in Singapore. Very happy to be here with all of you at the Global AM Summit virtually. And I hope to shed some light on how space, the space ecosystem in Singapore, is growing, and also how it affects 3D printing in space, which is also becoming a very hot topic today in discussions. So I quickly share with you a little bit about the SSTL, or the Singapore Space and Technology Limited. So we were previously an industry association. We've been founded since 2007. Developing a lot of Singapore's space and related satellite technology sectors. We support all areas of government, industry, and academia research activities within the space domain. And we also are a thought leader in some of the various space discussions and dialogues within the region. We spearhead ecosystem development activities to support our education programs, our accelerator programs. We work with startups, young innovators, and the global space sector in general that wants to engage with Singapore. Talent development is very close to our heart, hence why a lot of education and outreach activities is also championed by the SSTL. So a quick brief is the Singapore space journey. We have been around launching satellites since 2011. You can see that it's a short journey in terms of sending satellites into space. However, Singapore's research in satellites has gone back a couple of decades before. We are quite happy to share that Singapore has been sending up satellites on a fairly reasonable basis, and today we have about 14 satellites already sent into orbit, varying a degree of both commercial satellites as well as research institute satellites have been sent into orbit. A lot of it is remote sensing based. We look down and study various Earth applications and terrestrial applications, and some of them also are seen to also support commercial activities, not just for Singapore, but also for the region. We have a very wide ecosystem. Singapore's space landscape is, well, I would say, considering our short journey to space, it's fairly diverse. It's also grown exponentially since we started this commercial endeavor about a decade ago. It covers a very wide span of different categories where we have the manufacturers, the SATCOM providers, we have launch applications and also ground providers. We also have a very wide ecosystem of global partners and members as well. These members come from all walks of life, and we also support adjacent industries that are quite keen to participate in the space industry. The space sector is quite diverse. It covers a variety of subsectors, and it really diffuses technologies into many, many industries. So although when we say space, it's not really space for space, but also space for the aviation industry, aerospace. We have autonomous systems, electronics, precision engineering, infocoms and development, and so on and so forth. So we have a few technology innovation programs that we run within SSTL, and this is largely supporting Singapore's pursuit for the space sector. We run the Global Space and Technology Convention, an annual event since 2008 that draws about 1,000 or so participants globally to Singapore, and it covers a variety of topics, again, covering key areas and key industries that not only are partaking in the space sector specifically, but also are adjacent sectors supporting the ecosystem. The space sector in Singapore is quite keen to diversify, and perhaps we could even cover 3D printing as a sub-workshop that we cover, co-located with our main event on an annual basis. We also run our accelerator programs. These accelerator programs support startups, well, in a way sketch to scale, covering them as they come in their journey, and these young innovators are trying to grow and build new products to support a global challenge statements. We have two particular programs that I want to highlight. One is our primary accelerator that supports a whole string of activities, as you can see from the slides. Companies and startups, young organizations come in and they get access to subject matter experts. We also support their capitalization. We also support them gaining market access. And really, it is all kinds of activities in terms of technical due diligence and product expertise that we bring to the table to scale our young companies. We also partner with CapVista, DSTA's strategic VC arm, through a program called Project Cyclotron. This is more of a very deep tech program where we support younger companies that have very specialized tech specific to the space sector that needs a lot of acceleration in technology, as well as market access as well. We provide them a global expertise support where they can also reach out to companies within SSTL's global network to seek advice so that they can take it further and also accelerate into the region and beyond. We support the humanitarian and disaster relief efforts within Southeast Asia and to some degree also Asia Pacific as a whole through our HADR Challenge Innovation Programs. This program actually leverages on satellite technology. Supporting our neighbors, as you all know, Singapore is actually pretty fortunate that we do not have natural disasters. However, our neighbors are unfortunately affected by a string of them. And the SSTL has partnered some of our critical ecosystem players that support disaster relief efforts, such as the Regional Humanitarian and Disaster Crisis Center, RHCC, as well as the World Bank this year, to support and come up with innovative ideas, leveraging on satellite technology to solve problems and to also uplift our ecosystem here in understanding how best to tackle disasters. So every year, the challenge statement changes, whether it is to tackle earthquakes, tsunamis, coming up with applications that enables our young and our youth to also be aware of how best to support our neighbors. These are activities that bring to the forefront. And again, using satellites and eye in the sky is actually quite useful because in times of crisis, in large-scale disasters, satellites actually become a key piece of critical infrastructure to support these efforts. We also run workshops, small nano-satellite workshops. This is actually targeted in industry and also to support new companies, new people, new organizations and industry chaps that want to upskill and go into the satellite sector. Now, building a satellite is no mean feat, but in recent times, we have had commercialization of satellites take a quantum leap. So it is now smaller, cheaper, faster to build, and it is a lot easier to get these things to orbit. The technical training is conducted by SSTL and our partners, and we see a lot of this activity actually spurring young chaps to go into the satellite sector. Perhaps one day we can also include 3D printing into the satellite technology workshops because this is where we see the future moving towards. We run annual education challenges as well. The Singapore Space Challenge are one of our capstone programs since we started SSTL back in 2007, has been running, where it's a design engineering program where we get the best ideas actually germinated from our youth, our students. We cover them from universities all the way down to polytechnics, to upper secondary school students that participate in our annual Space Challenge, not only from Singapore, but we get quite a lot of participants vying for top spots, from the region. Every year, again, the design competition challenge statements change, but it's very relevant because we get industry experts to validate, industry experts to sit down and support and co-create and ideate with our students to solve real-world problems. And this, again, is something that we open up, and we are quite keen to have possibly 3D printing in space as a topic one day to support the growing movement that we are going to discuss in a bit. So let me cover a little bit about 3D printing and space technologies and why the relevance. I think we are all quite familiar. 3D printing is certainly something that has already taken most hardware industry sectors by storm. It's not new, and terrestrially, I think it is actually taking leaps and bounds in terms of supporting critical infrastructure. For space, in-space technologies is a little bit different. Creation of highly effective components. You want to mix things together. You need to reduce weight. You need to get things to space faster, better, cheaper. It's a bit difficult, and today's solutions tend to be quite weighty, resource intensive, very expensive for sure, and not easy. Furthermore, once you get to space, you also need to be sustainable, right? Being able to stay in space longer, being able to develop and build and keep manufacturing activities in space sustainable are topics that have been going around industry and keeping a lot of scientists up at night. It's not easy to sustain long endurance space missions, and this is actually one of the reasons why I guess today the space sector, when you talk about manned missions, exploration, or even sending our satellites further for deep space missions, tend to be somewhat challenging in the long term, unless we have a breakthrough, and 3D printing possibly could be that. So 3D printing in space, well, it really doesn't go back very far back. Since 2014, we've been trying to send up things to space. We've been trying to print a lot of things in space. The methodology and I guess the objective is quite straightforward. The more you can do in space and the cheaper you can get things up to space, the more sustainable and more viable a space mission is. Of course, you have to be safe as well. And, it's first of all, everything that is man-made here needs to actually survive and get into space. So sending up a 3D printer that you actually use in your backyard, for example, or at home is probably not the solution. It has to be hardened. You've got to make sure that the resources and the 3D print materials are also specially designed so they don't float around, and it could also cause gaseous, or it could also cause various activities that could be that could also not be very useful for the astronauts that are covering the space missions. And furthermore, 3D printing in space needs to take into consideration that whatever you send up adds weight as well. And as you can see, it's very expensive to send things up to space. So we need to make sure that whatever we do, whatever we build, whatever we design, for example, is first of all, it must have a useful application. And hopefully with 3D printing capabilities, that allows us to also be better at building and developing and sending products to space for more research activities. So it's really about how we can build faster, better, more complex solutions. And I will cover two areas. The two big areas here we cover is in rockets and satellites. Right. Today, there's a lot of examples of how younger companies, or even you can hear about our leading cutting-edge global space companies such as SpaceX, Rocket Lab, are building rockets that are using 3D printed parts already. Right. Whether it is the whole solution, and interestingly, we also have startups in Singapore that are also exploring 3D printed components for satellites and rockets. So whether it's the whole one piece, whether it is subsystems, these are all things that today are making rocketry solutions, rockets and launches more cost effective. The same thing for satellites, because today because of the democratization of satellite technology, things are becoming lower cost. Constellations of satellites are becoming quite the norm. You're sending up more and more satellites into space, and they can do a lot of things. Now, these satellites are coming off somewhat like a production line, right? And we are trying to get them all to be built in the same one-piece system, one-piece flow. And actually, for the primary bus systems and some of the sub-module assemblies, these are things that probably can be 3D printed once we get the form factors correct, and once we get the designs straight. Getting the right materials to 3D print satellites probably isn't something that is too futuristic. Now, we also want to make sure that we can recycle and reuse things on board, which is also something that our astronauts and also our manned missions are starting to explore. Because if you want to go further out, you need to be able to recycle everything. You recycle, reuse, and repeat. What you bring up, so that you don't have to worry about a resupply. The same thing also for some of our satellites. We want to have satellite mission extensions, for example, having 3D printed or autonomous 3D printing technologies, which is probably another breakthrough that we're all trying to get towards, would help support this entire arena of building and sustaining satellites in space is a big topic because, when you send things up, unlike other industries, they don't naturally come down all the time and you can't repair them. So you got to make sure that they can do their job, and they're fairly expensive. You got to make sure that they can be upgraded and they can continue being productive. So these are things that we want to support, and we believe will also take the industry forward, in time to come. We also look at 3D printing that supports terrestrial applications. One of them is being able to do biomanufacturing. And there are a lot of topics around this, and I won't go too much in depth, but essentially what you can do in space sometimes allows and sets the foundation for medical trials or terrestrially, whether it is using zero gravity to come up with new 3D printed muscle tissues that could possibly one day help and support organ development on the ground, or it could also provide testing for long-term space exploration effects that can also have certain effects on the human body. These are things that biomanufacturing, which really is the medical assist, the way we see it, can support all mankind in the future as well. And the last thing I want to cover is also sustainability in food. So yes, we have a whole spectrum of food options here on Earth. In space, not so straightforward. You can trial and test new ideas, and again, if you want to go further out, this is something that will probably have to be achieved before we really establish long-term boots on the ground, in various other manned missions that we are planning. So this also then can translate to how can we develop things on the move, and we can also create new recipes perhaps that can be deployed not just in space, but also for terrestrial applications. So one would see that essentially the future is quite all-encompassing for 3D printing. You can do a lot terrestrially on the ground. You certainly can do a lot in space, but both are actually quite intertwined, and that's how SSTL sees a lot of 3D printing activities in space. What we learn in space can be diffused, as I mentioned at the beginning, to multiple industry sectors, right? Everybody stands to gain, right? And ultimately, if you want to colonize, other planets like Mars, or even having lunar missions on scale, you probably need to put this together. And if you get it right, I guess, in space, you probably can do quite a lot terrestrially as well. So I think the future is actually very promising for 3D printing, and I hope that the space applications one day bear fruit and also benefit all of us terrestrially. Thank you very much.
Hello, thank you very much for having me. My name is Cheniuntai. I'm the CEO and founder of Appetit. We are the company that builds robots to print houses. Specifically, we are the developer and manufacturer of the unique 3D printers to 3D print the houses of any square footage and directly on site. And so we demonstrated the workability of our technology by recently delivering the world's largest 3D printed building in Dubai. And we also the finalist of the 3D printed habitat challenge organized by NASA. And so providing a little bit more information about our solution is that the main feature and advantage of our technology is the mobility and portability. And so that actually makes possible to 3D print houses of any square footage. It's because we can easily move the robot around the construction site and just keep printing as long as we literally have land available. And it's also wanted to notice that when we say to 3D print a house, that means that only wall structures are 3D printed. The remaining parts, like the foundation, roofing, windows installation, and installation of the reinforcement, still done the same way as we would do it for the traditionally built house. And it's still it's actually not a weak point of the technology, because we have to consider the 3D printers as automatic tools that help us to increase productivity and help us do the hard work faster and easier. Something like the electrical drills or bulldozers, right? So they help us to work faster and with the way less efforts involved in the process. And actually the 3D printers bring the automatization to the most labor and material intensive part of construction, the house structure. So that helps significantly increase the productivity for the overall construction process. And using this tool, we 3D printed the world's largest building in Dubai. Here you can see how it looks like. So this is the 2-story administrative building, the 9.5 meters tall, and the total square area is the 640 square meters. So that's basically the biggest building, 3D printed building today in the world. And the wall structures of this building were 3D printed directly on site, and the wall structures also were 3D printed continuously. So we didn't print the wall segments that then were assembled together. And so here you can see the example how we did it. And also you can see that the building footprint is much larger than the printer can cover with stationary. But again, because we have a mobile solution, we just move the printer portion by portion, and we 3D printed the building just piece by piece. And actually these pieces were connected together. It's not like the different separated pieces. And so as I also said that the building is 2-story building, this is how we 3D printed the second floor. So basically when we completed the 3D printing of the walls of the first floor, we installed the precast slabs and then put the printer on this precast slab. So basically we put the printer on the second floor and continued printing the wall structures of the second floor the same way as we was doing it for the first floor. Additionally, it's very important to say that the building is structurally reinforced, and we did the structural calculations to figure out where exactly the reinforcement should be placed. And the basic approach is that we 3D printed the formwork for structural columns that then were filled with the bars and regular concrete. And at the same time, we also 3D printed the self-bearing walls between the structural columns. So in this case, we 3D printed the building that completely structurally safe and sound. And this is how the building looks like right now after the finishing works. And so again, the wall structures were 3D printed by using our single machine. And this project is not only the big achievement for our company only, it's the breakthrough for the all 3D printing construction industry. Because first, we 3D printed a huge building on site, and we 3D printed it in uncontrolled climate conditions, meaning that we didn't have any tent covering the printing area to control the temperature and humidity. No, that conditions were completely uncontrolled, naturally available. And so that's actually a pretty challenging for 3D printing material, because it had to behave consistently no matter the changes of the temperature or humidity. And our team successfully managed to create such a material that would work perfectly and properly in such natural conditions. But after this project in Dubai, we started working on to create the solution how we can scale the technology and actually adopt it in the existing building codes and existing real construction industry. So the solution that how we 3D print houses has to be scalable, right? And so it's possible if we 3D print the structures which are the same all the time and which are structurally can be compared to something that already exists and already well accepted in construction industry. And so our team came up to the concept that we can compare our 3D printed structures to well-documented and reinforced accepted masonry, concrete masonry unit walls construction. And we already did the preliminary tests showing that our material and 3D printed wall structures meet the requirement for masonry. And basically, we have the 3D printed structure that structurally comparable to CMU wall structures. And having this proved, we can significantly simplify the designing process, how to design 3D printed buildings, how to go through the building approval processes, how to be sure that they structurally safe and sound, and actually to simplify the process, how to 3D print houses. Because we basically mimic everything that already implemented and done in the masonry construction. So, meaning that if you want to 3D print a house, you would do everything the same as you would do it for the traditionally built masonry house. The designing, the structural calculations, and the construction processes as well related to the foundation, roofing installation, doors and window schedules, and actually the reinforcement. It's also very important, how to reinforce the structures. Here you can see the example how we compare 3D printed wall structures with the CMU wall structures. And we are going to demonstrate it in a practical way through our next project in Louisiana, where we are going to 3D print a house with these specific wall designs. And later, it's going to be the feasibility study and supportive research for the next projects that also will be 3D printed with this specific wall design. That's the way that we see how we can scale the technology and adopt it in the construction industry. But that's everything was related to our work that we have been doing on Earth. To adopt and scale the technology on Earth. But actually the 3D printing, it's something that we need to deploy the habitats beyond Earth, on Moon and Mars, because everything there shall be done autonomously. The processes shall be done robotically, and these robots have to be operated remotely or their own. And everything actually shall be done by robots before first people arrive there. And robotics 3D printing technology is a good fit for that. And so pursuing this idea that someday we will be deploying and applying our technology for the construction in space, we participated in the 3D printed habitat challenge organized by NASA. And we participated jointly with the Search Plus company headquartered in New York. And the 3D printed habitat challenge is actually the multi-phases competition that divided to the several levels dedicated to design the habitats and actually to 3D print the prototypes and do the test with these 3D printed prototypes. Here you can see our designs of the future habitat on Mars, and this is the first our initial design that we submitted. And here you can see that the 3D printing technology used to 3D print the shell of a future of a habitat to protect the astronauts from the radiation, but at the same time it's 3D printed in the way when we still can provide the daylight to the habitat, inside the habitat. But beside the design, we also were tasked to 3D print the prototypes of the future habitat. It was the slab and another element. And the main task was to 3D print it in a maximum autonomous way that we successfully achieved. And additionally, we had to develop the material with the accordance to the specific competition requirements, and also carry out the test on the material and the 3D printed prototypes, like the impact test and water leakage test, to check whether or not there is any leakage going out from the 3D printed structure. And additionally, to 3D print the habitat in a maximum autonomous way, we also had to install the small elements of the habitat, again, robotically. So it was the integration of our 3D printer with the ABB robotic arm. And so it was the step-by-step and processes that actually the ABB robotics arm were involved, and to deliver some tasks during the 3D printing process. So it was a huge research work, and experience is very valuable, because something that we developed or tested to complete the task set by competition, this innovations and solutions are already integrated in our technology that we actually going to use first on Earth. So everything that we do to bring the technology in space have immediate application on Earth. And so that's actually everything that I wanted to share with you today. And thank you very much for your attention. And if you have any questions, just feel free to reach me out offline, and I would be happy to tell you more. Thank you very much.
Hi, my name's Adam Gilmour. I'm the CEO and founder of Gilmour Space. We've been around since 2014. We started the company in Singapore. We've expanded to Australia, and now we operate predominantly in Australia, where we have 55 employees. We're building a launch vehicle to take small satellites into space. We have 55 employees. We've raised 2 rounds of venture capital so far, totaling $26 million, and a number of government grants that total more than $4 million. I started the company with my brother James, and we've been having a great time building rockets and working on propulsion systems. And I'm very excited to talk to NAMIC about what we can do in additive manufacturing as well in the space industry. So the space industry is a very big industry. It's currently worth $366 billion US. A number of US investment banks have forecast that this industry will grow to around $1 trillion by 2040. Some of the biggest revenue increases will be in broadband internet from space. That's predicted to grow from roughly $2 billion a year now to more than $70 billion by 2040. And that has inspired a lot of companies, including SpaceX, OneWeb, and Amazon, to work on launching a whole lot of small satellites into low Earth orbit to go after this market. So where can we use additive manufacturing in space? In a lot of locations or a lot of places is the answer. But the good thing about space and additive manufacturing is rockets and satellites are not mass produced. You know, a very good rocket company makes 12 to 18 rockets a year. A very good satellite company maybe makes 100 satellites a year. So it's a product in an industry that doesn't need to have machines that pump out 50 things a day. What is produced by additive manufacturing in the world right now are many different things and many different components on the rocket, including rocket engines, valves, pumps, casings, structural members, fasteners, and other things that I haven't got listed here. If you look at what the trade-offs are compared to traditional manufacturing methods, generally the space industry has used additive manufacturing to trump the traditional ways. And many reasons why, but one of the main reasons is you can do much more complicated designs with additive manufacturing than you can with traditional machining, etc. And of course, additive manufacturing is fantastic for prototyping. So we use additive manufacturing for a lot of our prototype products. I've got a picture here of one of our rocket engines that we've been testing this year. There's a number of components in that rocket engine that are used with additive manufacturing. Some of the insulation, some of the fasteners, some of the structure around that. And that's just a taste of what we do. We have additive manufacturing in a lot of other products we have as well. If I look at what's been in the past and what's in the future, I've got some pictures here of some rocket engines. The one on the left-hand side is a Saturn V engine that was made with traditional manufacturing methods. So a lot of welding, brazing, etc. in here. If you look at the right-hand side, that's a cutaway of a liquid rocket engine that's using additive manufacturing. Now, why additive manufacturing is absolutely fantastic for liquid rocket engines in particular is one of the ways that you keep the temperature of the rocket chamber low is you have a whole lot of little tubes on the inside of the walls of the rocket engine that you flow liquids through. Generally, it's the fuel, and that liquid keeps the engine cool. And you need a whole lot of these tubes that are quite small. They can be a millimeter in diameter all through the engine. And then the other thing is when you're injecting the fuel into the rocket engine, you need a lot of small tubes as well. And for this kind of a process, additive manufacturing works really, really well. Almost all of the smaller rocket engines that are liquid rocket engines in the world now are made with additive manufacturing. So there's companies that are looking at additive manufacturing for even bigger structures. So we have a competitor in the United States called Relativity Space, and they're using additive manufacturing to make what they initially said was the entire launch vehicle, but what's ended up being major parts of the launch vehicle. So they're making the tanks, the fuselage, and the rocket engines with additive manufacturing. There's plenty of other things that they have to use with traditional manufacturing, but they're probably the greatest user of AM in the business. They've attracted quite a lot of venture capital, so a lot of the investors think this is a great way to use additive manufacturing. Even the big companies are using AM in space. So this is an example of an Airbus satellite part. The picture on the left is a traditional way that you would make this. It's cut pieces of metal that have been bolted together, welded together, or other ways of machining, screwing, etc. And then you can see if you conduct another type of analysis called topology analysis, where you run the system through a computer software that works out where the major stress points are in the structure, and you come up with what you have on the right-hand side, which is a 3D printed structure that would match the structural stiffness and capability of the original part, but with significantly less mass to it, and all done in one single system without any other fabrication, which is a great example of how AM can work very, very well. So AM's also being looked at in space, and I think that's where there could be a very, very big increase in productivity or use of AM is in space. One of the hardest things about working and living in space is making new things in space. So it's very hard to take an entire factory with you onto the surface of Mars or Moon, for example. So what NASA and a few other space agencies have been working on is what can you additively make in space on the surface of Mars, etc. So this picture here is NASA did a competition about could you make a habitat using a 3D printer and regolith type material that you'd find either on the surface of Mars or on the moon. And a lot of companies competed in this competition. One of the companies that won did a structure that looks very much like this picture here. We have also got a Space Act agreement with NASA. And one of the things that we are working on with NASA is inside of a habitat, you have a lot of different systems. You have life support systems, you have things that cook things, heat things up, cool things down. And how much of those systems can you make with additive manufacturing? And the idea is if you can take a 3D printer with you to Mars with a whole lot of material, you can start making things or spare parts, etc., with this 3D printer. So everything from structures inside the habitat to the habitat itself theoretically can be made with additive manufacturing. The other thing that people are looking at is how much can you additively manufacture actually in space itself, like in low Earth orbit. So we're talking to companies that are looking for opportunities to take raw material and 3D printers into space and start making structures in space. You know, these could be fuel depots or satellite refurbishment facilities, or even making spare parts for satellites in space. So there's a lot of opportunities to use additively manufactured things, not only on the surface of Earth to send into space, but in space itself. So I just wanted to finish off by saying I think that we've only really just begun in the journey of using AM-type technology in space. The last 5 years have seen a tremendous amount of AM technology used in propulsion systems especially. We're looking at it ourselves. And I think the next 10 to 20 years, the game will really be what can you do in space with AM that simplifies everything, which means you have to take less mass up into space, less machines up into space, and less different types of raw materials into space. And I think that's going to be a really big game changer to help humanity start moving and living and working in space in the future. And I'm very excited about that. So thank you very much. It's been my pleasure talking to everybody.
Thank you, Adam, Anna, and Jonathan. Space has always seemed so far away for many of us, but after hearing from our speakers, I think I'm excited to see what 3D printing can offer to our commercial space industry in the near future. But first, let's kick off a live panel discussion with our session chair, Aditya, and our distinguished panelists who are on standby. Aditya, if you're ready, sir, all over to you.
Yeah, great. Thanks, Mahindran. And it's been a pleasure listening to all of the speakers who've really brought diverse views and points, into this session today. And, I'm really interested to see what AM is already contributing to the space industry and what future may bring as well. It's quite exciting. And before we dive into the live panel discussion, I would like to take this opportunity to welcome Ms. Lynette Tan. She's the Chief Executive of Singapore Space and Technology Limited, who will be representing Mr. Jonathan Hung in this speaker panel, who's unfortunately unable to join us for this discussion. And great to share that Ms. Lynette Tan has recently been conveyed a spot in the Singapore's 100 Women in Tech list 2020 as the pioneering female leader with the space industry. I think that's something great, Lynette.
Thank you.
So I'm sure, you want to say something there?
No, just say thank you.
Yeah, no problem. So I'm sure many of you have left your questions for our speakers. If you have not, you can still leave them in the Q&A panel on the right, and we will begin the live panel discussion shortly. And so for those who would like to catch up on the playback of this session, it will be made available on the ITAP connected platform shortly to you. And, to move into the panel discussion along with, all the speakers and Lynette, you have brought in diverse views, where SSTL talks about the ecosystem, Anna is talking about the construction of various aspects, and Adam, you bring in the rocket part, and also the other futuristic areas like the habitat and the internal structures therein. So this is a general question, but to all the panelists. But I would like to it's more of summarizing the whole session for people to know. So basically, additive manufacturing has brought down the development time considerably, along with providing a lot of design flexibility in many manufacturing areas. So space is one of the most, I think, has been using AM for a lot of applications, and a lot of the conventional and even the new space companies, as shared by Adam and other speakers, they have been using AM quite a lot. So according to the panelists, maybe if you can list one or two items or one or 2 points where you feel is where AM is playing a big role today. Some of it might be repetition from your presentations, but what is, say, 1 or 2 points to you which AM is playing a big role today and for the future? So, if you could share your perspectives on that. So maybe starting.
I don't mind going first. I can tell you in the last 6 months, we've been finalising the design of a launch vehicle, and we've had a lot of occasions where we've got a particular part that's of a reasonable size. Could be anything from a 20 centimetre diameter and, half a metre long. And then we talk about, okay, we got to design, how do we manufacture it? And what's been fantastic is if we think it can fit into a 3D printer, first thing we do now is say, well, can we 3D print it? And if we can 3D print it within 2 or 3 weeks. And if we can't, it's at least a 3-month manufacturing process. So in terms of, if you want to go fast in developing prototypes, that's really what's great about 3D printers. Thanks.
Yeah. Lynette, would you like to add to that?
Yeah, so I think the time to production is a very attractive proposition, but also because, in space manufacturing, it's a very niche type of engineering. So they don't produce parts en masse, right? And therefore, space sector becomes a very suitable user for the additive manufacturing sector. And the AM benefits includes, being able to create complex high-performance parts in very small series. And it is a sector that is that understands that certain price points that's compatible with it. So that's why additive manufacturing in space and rocket design has always been a very popular topic for many, many years. You can do it with varying stiffness. You have internal structure, you have external structure. You can build, anisotropic components, and you can mix materials. So it's very attractive. And it is a sector that understands that it requires a niche design and manufacturing versus the commercial large scale where you're producing in the billions parts. And so that's why it's a very additive manufacturing development is very important in the space sector. Thank you. Yeah.
Anna, you'd like to add, from your point of view, what do you feel is, the big role AM is playing today and in the future? Not necessarily, one of it is construction, but, overall, what would your view be?
Yeah, I think that I would add more about the construction on Earth. And so the 3D printing technology, the robotics 3D printing construction technology, let's say it like in this way, it's actually dramatically reshapes the landscape of the overall construction and home building industry. It's not only about the speed of construction. It's more about the scalability of the construction processes that before actually wasn't really possible, And so the robotics construction, it's faster, but it also allows us to build differently. And for example, it allows to deliver the houses on schedule with the predictable time and with the predictable budget. And it's significantly changed the overall process. And for example, it really makes possible to change the home building industry and actually the to make the narrow between the how much we build today and how much we have to build today. In such countries like where the skilled labor is almost unavailable. So this is exactly how the 3D printing technology can reshape the overall process, how we can build houses. And about the space, it's also very, it's a giant thing, a giant technology for how we can build habitats beyond Earth, because there, of course, we have the limited capabilities, the environment is different, everything is different. And so the robotics is, of course, a very right answer how we can build something there. And yeah, so some days, and I assume pretty soon, we start building habitats beyond Earth, and 3D printing technology is the very important part of that. It's not the whole thing, but to 3D print the habitats there, yeah, it's the very important part that makes it possible. Yeah, because the additive manufacturing, it's how to create the volumetric objects, right? Rather than to build volumetric objects out of many small components and small materials, which is very labor and time intensive part. But additive manufacturing just creates the desired shape of something out of the, for example, in case for the construction, for 3D printing for construction, it's out of powder, right? It's the material, the dry mix mortars, that's the materials that we use to create the volumetric objects. So it's the smart way how to create volumetric objects like houses or habitats. Yeah.
Yeah, that's really interesting. And just one follow-up, question based on few advancements recently. And I'd like Anna to start, and maybe Adam and Lynette can also add. Is basically there's been a lot of research and work going on exploring local material for construction on the moon or for Mars. Obviously it's still a research, or it's still something which is proposed, but there have been projects where even the European Space Agency or similar are looking at perhaps repurposing local sand. So maybe it's the material on moon or material on Mars, because if we are looking at colonizing, we can't be carrying the premix from here to there, basically in terms of the weightage we carry to the space. So is there any work happening in this area, or is it too early to talk about it?
About the production of the materials beyond Earth, like to use the local materials? Yeah, so that's actually the one of the core points how we can go there, how we can do something on Mars, because we obviously cannot take a lot of materials from Earth. It's going to be very expensive, and sometimes it's not very viable. So we have to find a way how we have to, what materials we can use there, we have to use there, and how we actually have to produce them there. So the production of materials there on Moon and Mars, that's a very big question, and actually another challenge, right? Because again, to set up the production process on Earth, it's very challenging, right? And now we're talking about to set up the manufacturing process on Mars. So that's technologically, it's a very challenging part of how we can start building habitats there. And actually the production of material for 3D printing technology, it's not, we actually have to find a way how to produce the materials, not only for 3D printing habitats. There are a lot of manufacturing processes that should be there, like the fuel manufacturing there as well, because the rockets also will be there someday. So yeah, of course we have to use the local materials, and it's a lot of work ahead. What exact materials we should use there, and how we should produce them there for different processes.
Yeah. So if I could add and jump in, so I think what you've described is really the ideal end state and actually a holy grail to be able to achieve it. It's not saying we shouldn't, but just to put things in perspective, it's like Anna said, it's very, very challenging. There are two things also. So the 3D printers we develop on Earth, obviously when we use them on Moon or Mars, they would struggle because of the lack of gravity, right? The different gravity pull, and a lot of additive manufacturing, we understand you need that gravity for the things to stick together. So there is a machine that's designed for Earth's gravity using material on Earth, and then we're trying to put them to another celestial body, the Mars or Moon, which has a different gravity situation. Then you are trying to use a new material. And then the question then is that, does that new material work with the machine we've developed on Earth? And then it's actually a whole systems engineering changes. So actually the next step that we are looking at is really, I mean, not me, but, collectively the various organizations globally, is the machine we're going to develop on Earth, how is that going to work in space? No, in fact, I think that's the second step. The step now is actually, how do we use additive manufacturing in components that, like what Adam is doing to go to space first, leveraging on all these Earth constituents to create, more robust, better, faster, cheaper, more durable components. Then I think the next step is really manufacturing, over on another body, and then a lot of work that has to go behind to make it happen. It's very exciting. It's very attractive, but it's a very long road ahead of us, which means a lot of job security for many of us here. Thanks. Thank you.
I'll just add one more point. I went to a NASA facility at Kennedy where they do a lot of work on Moon, Mars stuff. And what they were doing was they found a material that was extremely similar to the Moon regolith. And they found it from a mine site somewhere in America. And what they were doing is they were using it as the base and then adding like an adhesive material. And then they'd done a series of prints of a little mini habitat. And you could see some of them just slumped very strongly because it wasn't strong enough. And then there was a point where they'd added enough adhesive material that it was nice and straight. And I think, that it comes down to, if you can take 20% of the whole build with adhesive and you can get 80% with core material, you're still winning. And I think that's what the next 10, 20, 30 years is for making structures on planetary surfaces. You use as much as you can and you bring the rest.
Yeah, thanks. And I know it's a very futuristic proposition, but if we, with whatever we're talking today about colonization, etc., I think it is something which will become an inevitability maybe 20, 30 years from now. So it's not something which is going to happen tomorrow. But I guess with all that, I think we'll have to also talk about the food all these people will need who will be working on those plants. That will be another challenge which will be coming up with when we're talking about colonizing other celestial bodies. I think that's something which is maybe a discussion for another time. But we have a lot of we have some questions coming in from the audience as well. But before that, I just want to have one question from my side. Is like obviously everyone's all your views will be different. But what is the one current challenge with additive manufacturing which you feel the AM industry or the stakeholders should address to amplify further adoption of this technology in your respective areas? Because all of you come from different areas, so the views could be different, and then the challenges could be different. So what would this be? If you want to pick one of the most pressing challenges for the industry to take care of.
I'm happy to go first. For us, it's size. Anything beyond, like if we need to metal print anything beyond 1 meter, it becomes very, very expensive. So I'd love to see more meter class, 1.5 meter class 3D print, metal 3D printers hit the market at a reasonable price.
Okay. Lynette or Anna, what would your one challenge be which
Yeah, for the construction 3D printing technology, it's really hard to say which one the big the big challenge, because the construction 3D printing technology is, again, reshapes the overall landscape of how we build houses. And the 3D printing technology, for example, if we just have a look at the process, how we build house today, and how we build it with the 3D printing technology, some of the processes really changed. Some of the processes just no need anymore to use them. So that's actually changed the infrastructure of the construction process. It's about the material delivery, about the material production, about how people should operate on the construction side. What exact the supply chain, how it works in case of the 3D printing technology. So that's also the challenge, how everybody has to shift to the new paradigm, right? So it takes some time of learning and adoption of the technology, because again, it's the new process, and it's not just one thing. It's really affect everything what we have done before and how we did it before. And the first is the infrastructure and how the overall process looks like. And another challenge also is the building codes and regulations. It's not something that's really impossible. It's just something that really requires some time, and it's something that not very easily to be fast changed, because the building codes and construction regulations are different from country to country, and the construction industry is highly regulated as well. So, and 3D printing technology is something that's never been introduced in the building codes. So it's, of course, that some time need to how to educate all of the stakeholders in this industry and how to adopt this new approach in each country. And even if we have some basic approach that can work in the United States, for example, it doesn't mean that it will immediately work in Middle East, for example, because they have their own procedures, their own standards, and all of these things. So it's again going to be the time how we go from the one country to another country. So this is the second challenge for the construction 3D printing technology. And so the last one, I would say, is that the 3D printing technology is about the robotics, about the materials, about the regulations, and so it's pretty capital intensive, right? And so the third challenge is about how to scale this technology and actually how to produce more machines, right? Because to produce 3D printers, we have to set up the manufacturing facility, and we have the other machines that we're going to build these machines. So it's all the time takes time. So it's not the pretty fast process, right? So yeah, to sum up my point of view, that for construction 3D printing technology, there is no one challenge. It's I would say, like the set of challenges that that we have, just because it's really new and innovative approach that reshapes everything and change the paradigm how we built houses 100 years before.
So
guys, it's a very exciting panel that's going on. Aditya, I got to jump in a little bit here because I'm excited to throw in some questions from the audiences. Actually, there's lots streaming in, and I think there are some very relevant questions that I think the panelists and yourself, Aditya, could take on. So let's have a look at the first question that has just come in. So this is to all of you, including Aditya. Feel free to answer. Do you feel that the community is very receptive or more receptive towards space technologies right now as compared to, say, 5 years ago? So maybe, Adam, you may kick it off first, and then the rest of you can jump in.
Yeah, sure. I think so. I think, one of the trends I've seen in the last 5 years is a lot more governments have realized how important space technology is. to everybody on the planet. And I know in Singapore and in Australia, there's been a lot more government focus on the benefits, and people realize that they rely on space technology for things they do every day of their lives. So I definitely feel like, the industry is getting a heck of a lot more attention, and positive attention. I mean, I have a general saying that, little kids like rockets and dinosaurs, and I think the general population definitely likes space.
Absolutely.
Yeah, if I could add, and I think to echo what Adam said, there's definitely a lot more receptiveness in at least trying to understand how space technologies could be applied, not just in space travel, but on Earth here. But we probably are still learning. So I think the issue is also. I also don't think there has been a sector that has as much movies made out of it than the space sector, right? In 2 years, you can have like 5 movies with time travel or space and rockets in the universe. The question is really to be very diligent in taking out the fiction and the facts, because you don't want to have an overhype, but you don't want to be dampening people's enthusiasm and excitement of the space industry. So it's a good balance. But I think what has been interesting in this sector is there's always a lot of movies around it that gets people, imagining that colonization could happen next year. And it would happen, it could happen, but it probably wouldn't be next year.
Exactly. Anna, would you like to add on a little bit on that?
Yeah, definitely the interest and how people really people attitude to the space exploration definitely changed over the last, I would say, 5 years or something. And I think that it's a great work that Elon Musk and his companies did for that. Because I truly believe that he could change our mind and actually brought our attention that we have to go to space and we can do this, right? And seeing their innovations and progress, it really looks like a reality, and we can believe what their companies and what Elon Musk really plans to do, right? And so I think, yeah, of course, thanks to such a companies like SpaceX, Blue Origin, the situation absolutely changed. And I think that we should have more people, more companies who will also promote this vision and promote this future when someday we will be there, and we actually have to be there. We have to go beyond Earth because we need to expand our ecosystem. So it's also very important to save our planet, not just to travel to space and explore new planets. It's also for our planet as well. And so the answer in the question, the situation absolutely changed, and we just need to have more companies and more people who also contribute in the promotion of this idea.
Yeah. Well, I totally agree with all of you on that one. And for sure, I think we need champions for space exploration and colonization. And we got a dream, right? Exactly like what Lynette that you had said. So I totally agree with you. And I think your son would also be very excited about that. So I've got another question here, which is pretty much shaping around that area as well. So all of you, what do you envision for the space industry in 5 years' time? How is it going to look like?
Quickly, step in and maybe let the experts, come in. So just quickly, I think what we've seen in the, looking at from my perspective in India, I think in the past 5 years, we've seen a lot of mindset change in terms of the government agencies becoming more open to allow private companies to start acting in the space exploration space. So just adding on to the last question and moving into this, I think, yes, I would agree it's been receptive. And I think going on in the next 5 years with the kind of a global momentum which is building, and I think it's going to be quite exciting on all the areas which were mentioned, in terms of building rockets, even for the smaller size satellite propulsion. You're talking about construction and also the food. I think the printing of food for space consumption, I think that could be an interesting area where some research and developments might be needed, because we're talking about sending a lot of people into space, so people need to eat. So we need to look at a faster way to service that. That could be an interesting area as well, along with obviously the technical aspects of building the rocket, the various spare parts in the engines, and the whole policy of the activity. So keeping that short, I think I'd like to hear what the other speakers have to say on this.
I'll go next. I think the next 5 years is going to be fantastic. I think things have been accelerating for the last 3 years. From my perspective on rockets, there's likely to be 3 or 4 countries that have access to space for the first time in the next 5 years, which will be fantastic. There's a couple of more really big rockets that are going to be tested in the next 2 or 3 years that will make Moon and Mars missions a lot more believable. SpaceX has got one, Blue Origin's got one, NASA's building the SLS, the Chinese have got a really big one coming. So I think that will enable a lot of big things to go into space, big space stations, big machines, and big things to land on the moon within about 5 years. So I think that's going to be really exciting.
Yeah. Well, maybe if I could speak for Singapore, we, as Singaporeans, we're always very proud. We are very strong proponents of technology adoption. We're very innovative. But the reality is the market size in Singapore is relatively small. Of course, we also talk about accessing the regional and global market. But even globally at the very large scale, it has been hard even for bigger companies, even SpaceX, to hit a revenue generating phase and hopefully a profit generating phase. And that is the reality, right? But I think there's a lot of optimism in the sector. And I really hope that in the next 3 to 5 years, we can start to have more companies who are revenue generating, hopefully into the profit generating phase. And then that will be truly a sustainable sector for people to continue to invest in.
So I think that for the next 5 years, so honestly, 5 years is not very enough time to demonstrate a very significant advancement, I would say. So, but I think that for the next 5 years we can see more research and development. I think that actually needed to plan the next space exploration. So, for example, for us. Before going to Mars or Moon and start 3D printing something, we first need to understand what the material is available there. So again, it takes some time to do this kind of research, do the simulations with the robotic solutions, with the material production, all of this stuff. So I would say that for the next 5 years, I assume that it would be more advancement in terms of the rockets and how we actually can travel there, the rockets and the spaceships. So, and actually, again, about the SpaceX, they again have a very ambitious plans and then in next 2-3 years to demonstrate their new spaceship, right? And that's going to be a very good, very significant advancement for all of the other linked industries. For us, example, right? So we have to send our robots to Mars, and we of course need to have a big rocket for that. So that would be, if we have this opportunity, that would be the significant advancement for us, right? That we can later plan for our business there. So yeah, I just would say that for the next 5 years, it's very short time to see a significant giant leap and go and step forward. But at the same time, it's very enough time Hello? Hello?
We hear you well, Anna, so keep going. Yeah.
Okay. Yeah, so for the next 5 years anyway, we're going to do a lot of research work that will serve as a base, right, and the trampoline for the next space exploration work. Yeah.
I think we have, Mahendra, I'll just, there's a question from the audience, which is a bit different, and it's not technical. It's more about the current situation we are in. It's more about resilience where companies are showing, So it's question to all three of you, what is the one challenge, or what challenges did you face during this pandemic? And, as you worked on your technologies in our areas, and how did you overcome it? Because that is something which I would like to know.
Yeah, I can go first if you want. When COVID started to really boot off, we had to put everyone on a shift. So we had 50% in the factory, 50% out of the factory. We did that for about 6 weeks. So we had a lot of people working from home, and then Australia's internet connection kind of failed quite often because everybody was suddenly using the internet to Skype and video call. But where I live in a state of Queensland, which has bounced back very, very quickly. So we came back to the factory within 6 weeks. The second effect, we're a venture-backed capital company. So when COVID hit, all the investors got really, really nervous and told us to, conserve your cash, don't hire aggressively, pull back everything. That only lasted about 3 or 4 months, and then the stock markets rallied and everybody got bullish again. But at the time, we were very nervous about what the next 2 years would look like, and we did stop hiring people for a while.
Yeah. Well, if I could add on to what Adam said, because Adam's pretty established in this part of the world. People know what he's doing. You talk to people who know about rockets, they will say, oh, Gilmour. So and therefore, I thought companies with a steady momentum can continue to, maybe they might slow down, but, company with good momentum like at Gilmour could continue to progress. And to link it to what Anna said, this is an industry with long gestation. We're trying to, with additive manufacturing, we're talking about shorter time horizon, but it's still relatively longer. So that became a blessing in disguise for many space tech companies. Including those that are under my portfolio in the accelerator program we run out of Singapore. We find that, maybe they have some delays, but generally it's within, plus and minus 10% of the whole project timeline. But companies that are established, like Gilmour, they will go at a good momentum and traction, and including SSTL, because we've been doing the space tech industry and development for almost 15 years. So we found that we became a beneficiary of it, because in this time where startups or companies that we are working with, again, a lot of the focus this year was on the startup and technology assistance for our startup companies, which we have 20 of them. They turn to us to say, I can't make that connection anymore. They don't know me. The investors get 20 decks, but because they know SSTL, we were able to say, hey, this is my portfolio company. Could you look at it? And in Singapore, because of how well, we've managed the situation, there was a circuit breaker where everything pretty much stopped still. But then we went back to phase 1 and phase 2. And again, being a small country, it was easier to meet. So I could actually, talk very frequently and even meet up over coffee with some startups and to understand where they're at. And then be that representative to talk to the potential partners and VCs who know SSTL super well. And therefore, we're actually hiring, we've increased our staff by 30%. In order to better support and serve the industry. So we turn out okay. I mean, knock on wood, we don't know when the light is coming at the end of the tunnel. But I thought this was a time where if you've got good projects, you've got a reputation, and you've got good momentum already, you're probably going to ride through it. But if you are really starting and you haven't met your first investor, or you haven't, hired your third guy, it's probably going to be really, really hard. Yeah. Thank you.
That's an interesting point. Anna, anything to add?
So I think that these times are more challenging for companies that dealing with the real world, right? Mainly manufacturing companies, who we are, for example. So because we build stuff together, so we all the time need the logistics is in place, all of the shipments and all of the parts delivered on time. And that was something that really were affected in the early this year. Now it's more, the situation got to normal, but in the beginning of this year, it was a big mess, right? Because the international logistics was highly affected, right? So that's something that really affected the companies who dealing with the real world, assembling something, producing something, manufacturing something. And so about the venture investment space, it's also interesting point that yes, again, in the beginning of this year, it was pretty hard to raise money because the venture capitalists, they were more focused to support their portfolio companies rather than to do new investments, right? But actually right now the situation again got pretty normal. So I think that all the situation caused by COVID right now, it's getting better and better because people just find the way how to live in this kind of situation. So yeah.
Okay, I think thanks. I think that's about the time we have for this session, and I'd like to thank all the
Aditya and our speakers, thank you so much. That was really, really an enriching discussion that I've just seen. Thank you so much again. And I hope everyone else got their burning questions out of the way as well. And we've heard from our speakers about how 3D printing can augment space exploration and even make commercial space travel possible at an affordable cost. Perhaps inhabiting space would not seem like such a distant thought after all, with 3D printing's ability to enhance the construction of space habitats. But that's not all of the emerging applications of 3D printing. Our fourth and final session today will give you a whole new perspective on what else AM can bring to the table in the healthcare industry. So stay tuned and join us after the break. Welcome back, and thank you for joining our final session on emerging applications today. Moderating this session, we have Joris coming live from Spain. He's the Vice President of Consulting at Smart Teck Analysis. Joris is also the Executive Editor at 3dprint.com, and he has spent over 12 years in the 3D printing industry, advising and working for both startups and multinationals in strategy, business development, and marketing roles. Joris, hola, ¿qué tal? Bien? How are you doing, my friend?
That was good. I'm doing well. How are you?
I'm good. So it's good to see you. You come from Holland, now you're in Spain. for a while, I suppose. How are things going on there? I mean, there's a thriving ecosystem for additive manufacturing there, right? So just tell us a little bit about it before we get into the action of things today.
Well, in Spain, it's very interesting, actually. And mostly around Barcelona, we see a real thriving ecosystem around HP, essentially. And then there's also BCN 3D, which is quite a big player on the desktop scene. There's lots of materials companies here working on it. And it's actually kind of finding its way into industry. So Spain's a very interesting country generally. And for additive manufacturing, it's starting to be a very interesting place as well. With a lot of companies adopting the technology and things like jigs and fixtures and manufacturing and stuff like that. So it was a very interesting time to be here.
Fantastic. So I think it is the right time. And it's also the right time for us to kick off our next session. And you're our session chair, and really delighted that you have taken your time. I know it's very early in the morning there in Spain, so fantastic. So all yours. Joris, take it away.
Hi, everyone. So we're trying to discuss today, we're going to have some presentations and a panel discussion on, I think, a very, very misunderstood and very, very unknown subject to most of the people in the industry, and that's 3D printing food. And 3D printing food for us is kind of something that's a bit weird or silly, or some people doing 3D printing chocolate for, essentially for fun and for the media. But we also may have noticed that there's a lot of things going on in your supermarket aisle, with a lot of meat replacements, a lot of protein replacements, a lot of engineered foods popping up in your supermarket aisle. And also, you probably have noticed that a lot of people have been showing an interest into alternative forms of protein, meat replacements, going vegan or going vegetarian, or partially doing this. And there's a lot of movement around nutrition and health, and everybody's looking for the magic bullet of nutrition, like one pill a day that could make you healthy. So these kind of things these trends are really sweeping the earth, and the success of Impossible Burger and similar companies in creating hype around manufactured foods is also a really, really idea that there's real business, there's real revenue behind this. So what role does 3D printing have to play in this? It could be obvious, or we could have no role whatsoever, and it's very interesting. So we're going to talk to 3 women today. We're going to hear presentations of them first. Later on, we're going to talk to them, and they're each in their own way trying to bring 3D printed food to your home. One of them is Dr. Li Kai. She's the chief scientific officer of Shiok Meats. Shiok Meats is a company that's going to use Li Kai and her co-founder's stem cell biologist expertise to develop to develop convenient, ethical, sustainable meat. She's focusing, or they're focused, Shiok Meats is actually focusing right now on seafood. And she's going to be talking to us about a cell-based seafood. So that's going to be very interesting. That's her way of doing it. Another person is Mrs. Gladys Wong. Gladys Wong is the chief senior principal dietitian and nutritionist at Khoo, Teck, Puat Hospital. I hope I pronounced that kind of okay. And she's looking at it through the prism of health. How can 3D printed food make it easier to give a balanced diet to somebody? How can 3D printed food make it easy for the elderly, for example, to have a good experience and also get the nutrition they need to make food that's easier to chew, for example? So she's looking at it through the prism of, as a hospital, how can they adopt this technology? And then we have Melissa Snover. Melissa is a founder for Nourish 3D, and Nourish 3D is doing personalized nutrition. So she wants to come up with a personalized nutrition product that's just for you. And your nutritional product would be very, very different than mine. So those are, I think, very, very different approaches to really trying to conquer this making 3D printed food a reality. And I'm really looking forward to later on, to talking to all 3 of us to talk together. At the same time, if you have a question at any time during the presentations, you can just put it in the comments section, and then we'll get to that at the end of the session. We can't promise to get to every question, but you can ask it just during the presentation whenever you want. So yeah, that's it really. And then thank you very much for listening to me right now. And let's get on to the presentations. And the first presentation is going to be Dr. Ling Kai and Bon Appetit, a cell-based seafood for a clean, sustainable future. Thank you.
Good afternoon, ladies and gentlemen. My name is Kai, and I'm the Chief Scientific Officer and co-founder of Shiok Meats. Thank you for inviting me to share with you our work at Shiok Meats and how 3D printing can be for the future of food at ITEP 2020. If you're not familiar with the word Shiok, it's actually a slang that's commonly used in Singapore and Malaysia that means fantastic and delicious. Our mission at Shiok Meats is to bring delicious and healthy crustacean meat by harvesting from cells instead of animals. We are the first cell-based crustacean startup and also the first cell-based startup in Singapore and Southeast Asia. Why we decided to work with shrimp and crustaceans is for a variety of reasons. Firstly, shrimp fraud is very common. A study done by Oceana in the US found that 30% of shrimp being sold in the groceries and restaurants are actually not what they say it is. It could come from a different country or maybe not the species which it claimed it is. In addition, with fishing, for every kilogram of shrimp that is being caught, 20 kilograms of other animal sea creatures are being sacrificed. Overfishing is also a huge issue as we continuously increase our consumption of seafood and crustaceans. And finally, for a lot of the shrimps and crustaceans in the oceans, they're polluted with the microplastics and other contaminants like mercury that are being found in the ocean. And this is impossible for us to clean out. In addition, for shrimp farming, in the very intensive and commercial farms, harmful chemicals are being used, for example, antibiotics, pesticides, bleach, just to clean them out of the conditions they're in. In addition, some of these shrimp farms requires the removal of mangroves, leading to a loss of biodiversity and tsunamis in these low-lying lands. And finally, if we're talking about deshelled frozen shrimp, slave laborers were used, paid in poor wages so that you can get the shells removed in an economical price. Further, other than shrimps, actually for lobsters and crabs, you are unable to farm them. You can actually only fish them from the ocean. With cell-based technology, this lets us to be able to create shrimp, crab, and lobster. Our shrimp, Shiok shrimp, is healthier, which needs no use of antibiotics or hormones. It grows 2 to 3 times faster because we grow specifically the muscle and fat that we eat. It's sustainable because we use less water and less land and can build up vertically. It's animal friendly. For each shrimp, we don't only get 1 shrimp to consume. And it's traceable. We know the source where we get the shrimp, crab, and lobster from, and we know exactly what we input the entire process until it's packaged and ready for commercial sales. This technology to produce cell-based crustaceans from stem cells is a technology that we built in Shiok Meats itself. We have filed the patent and is currently pending in the PCT stage. I like to describe the technology by comparing with the greenhouse and how we grow plants from there. So for plants, we can get a cutting from it, and then, but for animals like shrimp, we take the live muscle stem cells from the live animal. And then we need to provide it with a nutrient-rich environment that lets it to grow. But instead for plants, it uses greenhouse. For shrimps and other meats, we use bioreactors or fermenters, which are commonly used for beer brewing and soy sauce making. And then at the end of the process, we get minced meat product, which we can make into any type of shrimp products we're interested in. Just like at the end of the greenhouse growth, you get vegetables for your salad and dishes. With our technology, we have managed to do several internal tastings, and one of the public showcase we did was last year in March of our Shiok shrimp dumplings, or traditionally called siumais, which is made of pork and shrimp. In our case, we use a plant-based pork and mixed with our cell-based shrimp. Our tasters and advisors all had very good responses. It tastes just like shrimp, texture just like what they expect in a siumai. In terms of funding, Shoot Meats has raised up to 20.2 million US dollars for our seed and Series A funding for our research and pilot manufacturing plant setup. In our Series A round, we are very grateful to have aquaculture-specific fund, AquaSpark, and some of the Singapore and Asia supporters like Seeds Capital and Real Tech Fund to support us. Shoot Meats was started in 2018, almost 2 years ago, by Sandhya and myself. We're both stem cell and developmental biologists who have over 20 years of experience. We have now expanded our team to about over 14, and we're all made up of a variety of training in biology, engineering, bioprocessing, and food technology. And we're always on the lookout for like-minded, excited individuals to join us as well. The timeline for us, we've done a product launch, filed a patent, and then the next year we're focused on research and development to bring down the cost in terms of our culture media to feed what we feed the cells. And we're also in the midst of scaling up for our manufacturing plant production. We've also started our work in crab and lobster and hope to have our showcase later this year and next year. And then next year, we hope to have our pilot manufacturing plant set up in the second half of the year so that we can get ready for regulatory approval and by 2022, launch in 1 to 2 high-end restaurants in Singapore. So how does 3D printing and cell-based meats come together? A very good flowchart that is done by the GFI Good Food Institute in 2018 on cell-based meats has showcased that 3D printing is very important for scaffolding and structuring of the alternative meats. I think one of the very interesting part is that for 3D printing, you can come up with a lot of solutions that can be incorporated into different parts of the process. For example, microcarriers as part of the scaling up process in bioreactors, or hydrogels and scaffolds for the structure as we continue to differentiate our stem cells into muscle fibers. Some of the other things to incorporate and think about for 3D printing is what kind of materials can we use? Is it biodegradable? Can it be porous? How do you incorporate different tissue types together? The muscle, the fat, for mammalian cell types, it's a lot more complex where we need vascularization, the skin is also involved as well. And also the shape and the design, how does it come together? Can you tweak the texture, the firmness, the looks of it? And here are some of the examples of 3D printing being used in plant-based and cell-based meats in the last few years. Some of the challenges I foresee and have seen in some of the cell-based areas, the cost for 3D printing. Traditional 3D printing has been expensive, but in the last year or so, we've seen quite a few new startups and companies making use of 3D printing and bringing down the cost of making the scaffolds and microcarriers for cell-based purposes. In addition, large-scale production is also essential in order for commercialization of a food product. And what kind of bio-ink do we use for the 3D printing process? Is it food grade? Is it biodegradable? Or can we incorporate the gels with the cells itself and then print them out in layers so that, for example, for fish or for beef and pork, you can create the complex look and structure you're looking for. And finally, the texture and variability of 3D printing. The stiffness, the looks are all very essential for food products and the appeal to consumers. So this is the end of my presentation. Thank you for taking time to listen to me share about 3D printing and Shiok meats, and let's get the world to eat. Thank you.
Good afternoon. I'm Gladys Wong, Senior Principal Dietitian from Khoo Puat Hospital. Thank you to NAMIC for this opportunity to share with everybody about the advancing patient care with 3D printed food at this virtual Global AM Summit 2021. So I'm going to cover on the value proposition of 3D printed food in the healthcare industry with a specific target audience, which is close to my heart, which is the Asian population. Okay. Who needs dysphagia feeding, and also the reality and potentials of 3D food printing. This is United Nations World Population Aging 2019 report, and it says that the number of older people projected to double to 1.5 billion by 2050. So we are looking at what the silver generation is not dying any sooner, and they're living longer, both in sickness and in health, which means the ones who has got chronic diseases, who has got dementia, has got stroke, and also the ones who are old and frail, but still breathing and waking up every day. Okay, so there's two lots of people we have to take care of and to feed them properly. So Ministry of Health also admit that acknowledge that there is a aged care demand is actually, there's quite demanding. Okay, so we're looking at what there's also been able to provide daycare places, home care places, as well as nursing home beds all the time. So that's 2020, but there's definitely increasing need even now. So with the aging population, we're talking about pathologically or physiologically, there are issues, let's say, looking at stroke, muscle weakness, decline in immune function. That all can lead to decline in physical activity or poor oral hygiene. Then it leads to dysphagia, which is looking at swallowing difficulties, and also, more importantly, that we get malnutrition because they can't eat properly. Okay, and also if they can eat but improperly, then you may get aspiration pneumonia, which is just basically dislodge of infection in the lungs. So in Singapore, looking at dementia, which is an aging population disease in that sense, no, there's actually 1 out of 10 people above 60 years old suffers from dementia. And it's also projected by 2030 there'll be more than 152,000 people with actually dementia. So what is about dementia? See, it's looking at aging and dementia. It's a global issue. It's not only that, no, it's also looking at what we feed them. We have to actually feed all the people with dementia. Talking about difficulty in swallowing. It could be a serious health risk for those who have got dementia, suffering from eating difficulties. But the American Geriatric Society flatly says that there's no tube feeding, even though the people with dementia has got a problem with feeding. We don't put a tube down their nose. They recommend to endorse hand feeding by caregivers as a safe and more dignified, humane approach. So when you look at this then from a dietitian perspective, you know, if you're not safely feeding through the nose, you're talking about hand feeding, and there has to be a safety reason. That means what kind of food is a puree diet. Even more global is like looking at Australia, Canada, as well as America. Even with stroke, dementia, aging, we have issues of swallowing difficulty with dysphagia. So it is a global issue. Okay. So who needs a dysphagia diet then? Okay, talking about puree diet, so the frail elderly, though healthy, may have ill-fitted dentures and unable to chew effectively and swallow safely. So there's also the sick elderly, which may be due to stroke, and this could be also young people as well, who has got stroke and progressive dementia, resulting in chewing and swallowing difficulties. Then we have those majority who are not too sick, but they just need a puree diet to minimize chewing effect, chewing fatigue, as well as to prevent choking risk. So to us dietitians, you know, food is not nutrition unless it's really eaten. Otherwise, we have to look at things like preventing malnutrition. So it's a vested interest that we make sure the food that is puree diet is nice, visually palatable to eat. Okay? So this is the WHO 2016 to 2020 action plan on the aging and health. There is the new one that's out to 2025, but I'm looking at the old one at the moment because the new one is not really on the internet yet. Huh? Okay, strengthen long-term care. We are talking about to allow older people to live with dignity. So that, to me, interpretation, it means that we have to also feed them safely with dignified care, okay, with dignity. Ideally, we hope the left picture is what everybody will age to be, you know, eat and enjoy life. Huh? But in reality, there'll be a lot of us that will be end up in nursing homes, sitting in a wheelchair day in, day out, and being fed by someone else. Okay, if that's the case, how do you want to be fed? Then is it food like this? Okay, there's actually all blobs together, and then halfway through it will all be mashed up into this looking blobs. Right? So how to feed with dignified care? So when I grow old, I wish that I will be fed safely, okay, with personalized, palatable, and visually presentable puree food from a dignified and pleasurable experience, dining experience that is affordable every time. So looking at safety and visually, I want to be able to see the food that it looks nice, that I'm willing to eat it and morishly eat more. Right. So Dr. Mary Ann Sau from Sau Foundation in June this year in Straits Times also reported to say that all have a role in helping the elderly age with dignity. That means a standard of living that embraces dignified care as well as respect. So really, we know that silver generation is living longer, okay, in sickness and health. There is increasing frail aging population looking at cardiovascular and degenerative diseases, such as dementia, okay? So we need to feed the masses, the frail elderly, the one with stroke, with dementia, in hospitals, nursing homes, and community of what? Of consistent modified texture and consistently. So we're not even talking about the 80-20 rule of looking at the therapeutic diets and looking at precision nutrition. I'm just looking at just changing the texture so that majority of the patients will eat it. And the ones that are old and they're all living in the community, in the hospitals, or even nursing homes. So what about the reality of potentials of 3D food printing then? Okay, so I think the reality is really the way to go. Okay, it is really innovative food service of the future. We do have 3D molding now that's being done, but they're all individual foods that's actually placed on the plate. But if you're looking at really pleasurable looking at 3D printed meals, right, I think that's the way to go. Actual palatable and printable food inks with safe and stable shelf life. We have to exploit technology and AI, improve productivity, and redesign job scopes. Okay, looking at exploring, exploiting, and transforming a digital world to go. Okay, feeding real food as well, making sure the food is safe. Even looking at the global food thickening agent, okay, because when you print the food, you need a thickening agent to be able to solidify or at least gel the thing so it actually holds its shape. So what has been projected now is expected to reach $156,000 million, okay, by 2026. So there is an investment out there for that part of the 3D food printing. So the entrepreneur's idea of a novelty kind of 3D food printing really is looking at pancakes, making fancy pancakes, icings, sugar on the cake, and chocolate. But you see, from a dietitian's perspective, and especially in the Asian context, I want to be able to print, or I want somebody to be able to print Asian dishes. Okay, Asian dishes that looks like this. Can you imagine when you grow old, you're sitting in a wheelchair with a stroke, you cannot swallow properly, you're drooling down your saliva down the side, and you need to have a puree diet. Okay, a puree diet, you'll be looking at this kind of food, and then when you actually, like this one, a char kway teow, but when you put a fork through, it's a mousse texture. That's what I'm looking at. I like this picture is because of the fishball, because people, old people especially, do actually choke on fishball and die from it or near death. So if I can print a dish out that looks like this, the old man can enjoy eating it, okay, safely, because everything is just a puree diet. Possible with 3D food printing. Is that what you want when you grow old? Think about it. So Singapore Centre of Digital Gastrostomy is a place where we have a team of people working quite hard on the 3D food printing. They're from SUTD, NTU, and collaboration with Khoo Puat Hospital. We had some sponsorship from NAMIC as well as from SUTD to do this. So this is one of the projects that's done up to date now with the food puree inks, looking at all the vegetables that we can print. We have been featured in the Channel News Asia in February this year. So if you want to Google Google with a YouTube, look for the 3D food printing desserts to hospital meals. There's just a little clip about the projects that we're doing. SUTD also has a lecturer that's looking at food upcycling, looking at jackfruits, okay, and how we can recycle with it. So 3D food printing can do sustainability as well, looking at sustainable environment, sustainability of food security. So globally, there is no commercially viable institutional 3D food printer as yet. Okay? Hopefully we'll have some soon. So 3D food printing is not just a novelty. I think it has to be a reality for our aging population, especially now with the new COVID, with the new normal. It is becoming even more apparent to actually look at preparing and sustainability of food. The 3D food printing may provide a way to actually feed the whole world. Okay, that's what Forbes reckons. They can project the thing, the industry to expected to reach $250 billion by 2022. And the 3D food printing market is projected to reach 2023, $525 million. Okay, so but what it is also the challenge that we have is how to make it a sustainable food manufacturing system that can feed the increasing global population. And it's not just the elderly population with dysphagia. So now we talk about increasing population. I mean, the COVID did kill a few people, but life still goes on, and there'll still be a lot of increasing mouths that we have to feed, stomachs that we have to feed. This is Netherlands looking at gastrostomy for frail seniors, okay, and how they can feed for themselves. They look quite independent, but they look old, isn't it? Okay, with chewing and swallowing difficulties by working on printed versions of the meat and vegetables. That's what they're doing. This is in Germany in 2018, where they're looking at the first multi-head or 3D food printing system. Okay, and they're looking at a catering outlet where they supply to numerous old people's homes and hospitals in Germany. With the future, we'll see the potential of customer self-development. So this is what they have down here. But these are still quite individual. But when you look at the Asian diet is where we are hoping our vested interest. That means a mixed meal diet, but single dish. Food service of future is 3D food printing, I think. Without 3D food printing, I think we need a lot of M's. Okay, molds, manpower, money, and monitoring. There's no guarantee of consistency of nutrition, malnutrition, as well as the texture swallowing difficulties. You want to print using real food, we can also print using not real food. That means the food technology can print anything that looks, smell, and tastes like the real food. So the meat industry are also very interested. Okay, the new food for the aged care in the restaurants. The people who are not selling meat, but selling meat alternatives are also very interested. See, there's all this meat market in the 3D food printing world. $140 billion by 2029. Okay. From healthcare perspective, as long as food inks has protein rich, I think that's our main concern. It must be a meat protein, cereal protein, vegetable, insect protein, doesn't matter. Whatever it is, as long as protein, because that's what the elderly needs to prevent sarcopenia, that means muscle wastage. Okay, that's a nutritional need of the elderly. Okay, so we think big, start small, and end in mind is to have safe feeding of our frail elderly and those with swallowing difficulties, consistently prepared and presented, dignified and pleasurable dining, nutritionally adequate tailored meals to the nursing homes and free living lonelies, and then we look at personalized nutrition and mass customization. 3D food printing has a long-term financial feasibility as well. You can actually have the economy of scale to the masses. We also can have premium production to those who can actually afford it. So I think it is quite a good business proposition in that sense. Okay, Nestle also wants to meet the dietary needs of the 3D food printing. You see, they also reported to say they want to create meals that's tailored to the nutritional needs of the individual. So there are many kinds of things that we can meet for individuals, especially with the elderly population. I hope I covered on who needs a dysphagia diet and the reality and potentials of 3D food printing. I think we'll just spend more time at the panel discussion to discuss more questions. Thank you. So aging population in sickness and in health, in hospital, nursing homes and community. Disruptive food innovation is the dignified and safe feeding of the elderly, personalized nutrition, global food security, sustainability, and minimizing food waste. When we look at 3D food printing, I think it's our next journey into food imagination as well as food innovation. Thank you.
Hi, I'm Melissa Snover, the CEO and founder at Remedy Health. Here at Remedy, it's our mission to use 3D printing technology to personalize the sectors of health and wellness. I started my career in FMCG in 2010 when I created and launched the world's first vegan, allergen-free gummy candy range called Goody Good Stuff. I grew that to 40,000 stores distribution in under 3 years and sold it to Cloetta PLC in 2014. On the back of my frustrations that I experienced while developing, creating, and making good stuff, particularly around the limitations of traditional mainstream manufacturing, the very long MPD lead times, and the massive minimum order quantities, I decided I wanted to create a way for consumers to make their own products, as this was the only way I could imagine solving the problem of not being able to make enough variations for everyone to be happy. So in 2015, I joined forces with Katjes Germany and developed the world's first FDA and FSA approved 3D food printer called the Magic Candy Factory. We launched that concept in 150 locations globally in under 2 years. And if you could still travel today, you could find it at Hong Kong Duty Free, Warner Brothers World, Dubai Mall, and many other places. But the #1 selling product the Magic Candy Factory makes is something called a sweet selfie. It's basically a candy of your face. And though this is delightful and educational, it certainly didn't have the global impact I had as a vision for the technology we'd created. So in 2018, my team and I sat down and started to develop new ways of applying our technology across the health and wellness sectors, and developed our new technologies for Remedy Health, over 100,000 hours in the lab, 20,000 third-party tests, and 18 months of R&D. And we launched Remedy in May of 2019. We have created an impressive IP library of over 10 patented technologies, multiple proprietary software algorithms, and an unquantifiable amount of expertise and know-how. And we currently are applying these different IPs across 2 different concepts: Nourished, our preventative health solution for personalized vitamins and supplements, and Scripted, our curative health solution using 3D printing to create localized and personalized dosages of medication for patients, optimize clinical trials, and in the future, even polypills. Nourished is the world's first truly personalized supplement. By answering a few short questions on our online app, our clever algorithm will take information about your health, lifestyle, and goals and create a personal recommendation of 7 nourishments best suited to you from our extensive list of 28 different vitamins, minerals, superfoods, and actives. We then 3D print them for you in our Birmingham-based facility, where we have full stack manufacturing capability, and ship them to your door every month in 100% plastic-free, home compostable packaging. What's more, all of the recipes, ingredients, and processes at our facility are sugar-free, allergen-free, and vegan. And because we make your product fresh to order, we can guarantee 99.5% manufacturer input efficacy. On top of all of the disruption our current product is having in the market, the real advantage of our technology is the ability to create rapid and unlimited variations and iterations in real time. In effect, we can create a new and unique product in our facility in Birmingham every 5 minutes, and we can add new nourishments in as little as 10 days, allowing us to respond to customer feedback, new research, and global trends like health crises such as COVID-19 to be able to continually offer the absolute best and most time-worthy products to the consumer, bettering their lives and being meaningful as a business in our contribution. In addition, my team and I have been working with doctors and patient care providers, as well as health organizations over the last 18 months to apply our 3D printing technology to medicine. In the first instance, we are currently working on our second human trial where we are allowing doctors, patient care providers, and pharmacists to create personalized and customized dosages of medication on the fly specific to the user. This eliminates incorrect dosaging, allows for multiple iterations which are not available on the common market, eliminates wastage of drugs, and makes the entire experience and the medium where the excipient is enclosed more pleasant for the user, which increases adherence. In the future, we intend to use our patented material science with multiple encapsulation layers to control dispersion rates of different drugs through the bloodstream at different times, eliminating the need for multiple pills throughout the day, and eventually also linking DNA, microbiome, and other biometric testing to doctors so that they are able to create the best and most effective regimes for patients on the fly. We will be going to our second trial in October 2020, where we'll be testing 5 different drugs around pediatric medications. We launched our Nourish product in the winter of 2019 in the UK in our beta test, and since then have amassed 3,500 plus customers in under 8 months. We are enjoying 20% plus month-on-month growth CAGR, And in September of this year, we launched our US web beta launch. We're currently working on rolling out our Nourish Kids product for the UK. And at the beginning of next week, we'll be starting our Q4 Series A funding round, the funds of which will be used for US global expansion, further advancement of our medical project, and the development of Nourish Protein. Thank you very much for your time. Happy to take any questions.
Thank you, our speakers, Melissa, Gladys, and Kai. Fantastic. Really enjoyed all of that. So, all right, folks, it's been an enriching summit so far, and we are down to our final portion of the event. So stick around as we will soon engage our speakers in a live panel discussion. Joris and the panelists will be diving deeper and providing us with cool insights as well as answering your questions. But Joris, I'm going to just look out for you, and I'm going to ask a few questions to you. I mean, you know, how cool would it be if we had our own 3D printer in our living room, our kitchen, and we can print our own breakfast? I mean, you're getting ready for breakfast now, and I just skipped lunch to do this thing. But how cool would it be if we had our own printers, you know, to print our meals? What do you think? And what have you seen so far that excites you?
I'm not really that excited by the printing food, actual food at home, because I think cooking is a really wonderful activity and that takes away from it. What I'm more excited about is like personal nutrition for in the home, for example, in-home, like a kind of Nespresso machine for personalized nutrition or supplements and things like that. That I think is really interesting as a model. And I'm also very interested in just generally somebody doing like, the interesting thing about what Shiok Meats is doing is they're going for crustaceans, right? There's one company doing 3D printed fish. There's a bunch of companies trying steak. But then there's a whole lot of other things that are open, right? So there's a ton of different foods that can be approached. So you could be the first in the water with, for example, Gladys touched on fish balls. I've written an article about this as well, because pretty much anything can be a fish ball. And you could just have a very viable startup just focusing on fish balls. And if you look at the outcomes, you don't have to have a big exit. There's a lot of exit partners for a company like that. If you made like surimi, or if you made things like mushrooms or other types of foods. So there would be a lot of options for you as an exit. There'd be a lot of options for you to be a very sustainable player in fish balls in the Singapore market, for example. So I think there's a really a lot of exciting startups that can come from this, and there's a lot of unclaimed territory.
Yes.
It's only steak, burgers, mincemeat is really the focus.
Exactly. I mean, that's the popular food now, right? So everybody wants to have burgers and fries and all that's 3D printed. But I guess there's more for this sector to offer. And I think the panelists are all ready for you now, and they are all waiting to share and have an engaging conversation with you. So let's listen in to you and the panelists. Over to you, Joris.
Hi, guys. So thank you so much for your presentations, everyone. Thanks, everyone. So first off, I think it's interesting that you're all approaching this in your very different way. So I'd like to really think of this. I think what viewers really want to know is how close is this? So I'd like to ask all of you, how close is 3D printing of food, and how big a part will 3D printing food play in the world? So maybe start with Gladys first, and then we'll go around. What do you think, Gladys?
Well, personally, I wanted it yesterday and a few years ago. But when you look at 3D food printing, I think there's really as good as how many investors, financial investors, that we can get into this in order to invest in developing the food inks as well as the machine, the printers, to get it happening. But if you look at the increasing aging population, as well as the escalation of the growth of expansion of aging population, and also with the 3D printing and 3D food printing, I hope by next year or the following year that something will be happening at a commercial level.
Okay. And Melissa, what do you think?
Yeah, I mean, I started 3D printing food in 2015, and we developed the world's first FDA and FSA compliant food printer for live food printing. I think the hygiene element of being able to create a multitude of different products with a 3D printer, but then still assure
the same level of GMP, BRC, cleanliness, and also integrity of the final product is one of the big stumbling blocks a lot of 3D printing companies come across, because 3D printing something in a lab as opposed to 3D printing something in someone's home, like you mentioned at the beginning, is a very different level of regulation and statutes around it. So, I mean, as far as when is it going to market, I mean, we've been selling 3D printed gummy vitamin supplements in the UK for almost a year now. The response from the market is hugely positive, and the business is growing massively. A bit what Gladys said before, it is all about how many people believe in this concept being world-changing and investment coming into the different startups that are developing these cool ideas. We were very lucky to secure the largest female founder seed round in the UK for our idea, and we're just on our Series A right now, where we're raising $10 million to expand into the US, and also additional food formats like 3D printing of protein bars, which is a new and also a very popular format for food, which can be personalized to the individual. So for me and for our business, it's out there and it's getting a really positive response. The multitude of different options and it being mainstream and one of the ways that you make your food, I think is probably about 5 years away.
Okay. And Kai?
Great. I think for us, we're looking to get into market in 2 years or so from now. I wouldn't say our first product will be 3D printed. That will probably come a bit later in a few more years when we're looking to get a more textured product that looks and feels like the traditional shrimp or lobster and crab that we're familiar with seeing. And that's kind of the timeline we've seen with other cell-based companies around the world. Because the technology that's hindering us is not really 3D printing per se. I mean, like Melissa and you guys have mentioned that it's already in use. It's just that for us, we're still developing the rest of the technology to scale up how we produce the proteins. And then for us is to also create the shape and texture that consumers are used to. So there's another aspect of it that comes into play where we need to develop this technology hand in hand. So I would say probably in the next 2 to 5 years, consumers like you and I will start seeing this probably in restaurants first to start, and then later on in grocery stores.
Yeah. Okay, that's interesting. What really intrigues me about this whole category essentially is you've got like the gummy bears example from Melissa's example. That's a ready-to-eat product. That's just sui generis is the product, and you buy it. On the Impossible Burger front and all these things, they're trying to very much make something that kind of looks like mincemeat in the packaging and that behaves and performs like mincemeat once you've cooked it, right? Gladys, on the other hand, is trying to make something that, well, it needs to feel familiar, and it means trying to activate those food memories and those experiences and make it pleasurable, right? Mm-hmm. So to me, the interesting bit is, where do you focus on? I mean, do you focus on making something that looks, because what I always thought is like, well, why don't we just make like for example, a shrimp example. Why don't we just make a shrimp that tastes already like the shrimp, and then you put one of those flame things on it, you know? Why don't we make that a bit fun? Are we wedded to the cooking as a concept? Right? Do you guys want to make something that people will cook, or do you want to make something that people will eat? Does that make sense as a question, Gladys, for example?
Yeah. What we really want from a healthcare perspective is to get food that is pureed and yet is visually appealing. So it's visually appealing that looks like real food that the elderly population or those who has got stroke or swallowing difficulties or chewing difficulties are willing to open their mouth and eat it. And when they want to eat it, they will actually eat and eat more of it so that we can get the nutrition in. Yeah, so it's really for the healthcare perspective, it's really looking at feeding the masses first, which is looking at feeding with texture modified foods that is safe for swallowing. So when all the others come in with different kind of fish ball that is not fish or shrimp that's real shrimp or non-shrimp that tastes like shrimp, that for us will come in later. There will be a different market that we are targeting at. But for the healthcare, we are talking about safe swallowing. That means it's food that is pureed, that it is It is, there is happening now with the puree diets that you can just sort of use a blender and mold it and then just use spoons and ice cream scoops and just shove it into people's mouth. But if you have it visually attractive, then that's where we're talking about dignified care for the elderly population, for you and me when we grow old. You see, so that's the safety issue that we're coming from.
Yeah, I think that's a really wonderful thing you're doing, by the way. And then and what role does individualized nutrition have to play in that thing? Is it really doable that you're going to like weigh a patient and then look at where they are and the disease and then give them the nutrition on the day that they need? Is that something you're looking at as well?
Yes, that would be something that we'll be looking into. If you're looking at with Innovation 4.0, that would be where it will come in with the AI that you don't even need a dietitian later on, because all I need to do is just have all the indicators all plugged in, all the figures, your weight and the height, your blood test results, and then you have a recipe down there, and the recipe can sort of modify itself, and you can print a bigger burger, you can print a bigger slab of tomato sauce, or sort of a different kind of a protein, or different protein that you can just increase the protein intake, the vitamin D or calcium intake. Yeah, so that it becomes personalized later on. But before we even get to that stage, I think we need to really feed just the texture modified diet, just to get that concept correct, the basic feeding the masses first. Then we'll come into the personalized nutrition, which will be the potentially the higher end, that we can be more specific and reduce the manpower, which is increased productivity.
If I could say, we're actually already doing linkages and data set integrations with biometric tests from DNA, microbiome, and drug blood work, as well as, which is absolutely necessary on top, phenotyping questions around things like, height, weight, but also what is your existing health condition? What is your lifestyle like? What are you going to be doing? Of course, people in care are a little bit different. Their lifestyle varies less maybe than somebody, just out in the mass market. But then in addition to that, we're always asking people, what is the real goal as to why you're looking to functional nutrition? What are you trying to achieve? Because that's another very important decision-making point. With all of that data, our algorithm and recommendation engine produces from a list of, I think, 35 now, different nutrients from, vitamins, minerals, superfoods, and actives, a combination of 7, which are specific to that individual based on the data that has been put into the system. And that could then be used in an application like Gladys's, which I fully agree is so necessary. We also work with aging population in medicine and coming up with chewables for them to be able to take medicine, so pharmacological compounds, because they do struggle to swallow. Some people can't and some people won't. So either way. But in the future, the perfect world solution that we always think about when we do our big dream thinking is, think about your kitchen, the mainstream market, and think about the appliances that sit on your shelf in your kitchen, which is a limited amount of space. Depending on where you live in the world, it's more or less limited. But every single device you have in that kitchen, your refrigerator, your microwave, your blender, whatever it is that gets a place on the top, it can make multiple things. So as long as 3D printers are limited to make a very small amount of variations, they're never going to deserve a place on a kitchen shelf. But in our big world dream, we can imagine a 3D printer on your kitchen shelf, which is taking data from a sensor in your arm and telling the printer that, Melissa didn't sleep well today and she's very low on vitamin D. And then my printer is making for me that morning, whatever, my cranberry raspberry scone fortified with extra protein and vitamin D, which is what I need that morning. And that is possible in the long run. But when you asked your first question, it was about, do you envision that people should have to cook it? In my perfect world scenario, the 3D printer puts out a series of materials, blends them in line, and then actually cooks them within the machine so that it's so easy. It's like a smartphone for personalized food at home.
And so then to Dr. Ling then, so about like you guys are developing a product based on cells and stem cells and using that. Do you think that's a better approach? Why is that a better approach than, for example, starting with some kind of protein or starting with a mushroom and then making that mushroom taste like fish? Why is it? What's better about that approach of using cells?
I mean, I think cells is basically the factory in our body making different nutrients and stuff. If we go straight to the protein level, then we're only focusing on the protein, and our diets are not just made out of protein. The cells themselves, even though we focus on muscle and fat, they each produce a variety of nutrients, not just specific proteins that we're looking into. So that overall gives us a more closer imitation of what we generally eat as a diet here. And also what we're looking for, I mean, why we started this is basically to provide an alternative method to produce how we're producing our meats at the moment, which is either fishing or farming, going into the nature. So we're just providing an alternative method to do it. But like what Gladys and Melissa said, I mean, being able to produce the cells or even proteins at individual levels, that gives us a way to make use of techniques like 3D printing to make personalized nutrition in the future, not just in terms of like, you know, how we associate with it now that there are more like protein bars or shakes that we have. They could become more savory food types, but especially like if we look into seafood, where a lot of people are concerned that, oh, there's high cholesterol, so I should cut down my seafood intake. But with that, how do you do that right now unless you can separate out the components? But with cell-based meats, because we're basically having different building blocks, we can piece together ones that are only protein rich focus, and then we replace the fats with like omega-3 fats instead of what is found in the nature for it that might not be suitable for people with certain health issues. So that's really quite an interesting take on it. And to kind of come back to the question you were asking, whether we need to cook or not, that I think that would be a good place for especially seafood, because a lot of seafood we tend to eat as raw sashimi. So we don't have to think about cooking for it at all. But why I think we consumers, a lot of us enjoy different types of food is because there is different cooking that we do with it that makes, you know, one kind of ingredient with many different outcomes. But it doesn't mean that we have to just rely on cooking methods after we 3D print it. We could cook the ingredients beforehand to provide it with the flavor profiles. And there are also a lot of flavoring companies out there who have characterized very unique flavor molecules that are associated with different kinds of cooking, whether it's steaming, frying, deep frying, sous vide, and those are things that can all be incorporated, especially when we think about such a versatile technology like 3D printing, where we can incorporate a lot of things to blend together.
Also, again, for Dr. Ling, I was wondering, like, so, you know, well, where, if you're doing the cell-based approach, where does it get difficult? I mean, is it difficult in the research stage? Is it difficult to go into a pilot production, or is like actual production the real big bottleneck? If we're looking at like millions of doses and things, where are the difficult areas, the bottlenecks in your development path?
Yeah, the biggest challenges for us are to bring up the scale. I mean, from doing it in a small scale in the lab versus producing it in large scale, things that need to happen are the equipment to produce it. Like what Melissa said, you know, to be able to have a food grade certified equipment, it's not trivial. What we have traditionally been done, it's mostly pharmaceutical, and everybody is trying to, you know, we can go in and continue with pharmaceutical, but as a production cost, then that means a lot more high costs with maintenance and production, and that's not what we need. So, you know, we have to get different players to talk together, the equipment, the ingredient supply as well, to be able, we need to grow our cells, we need to feed them with ingredients, and we need suppliers from the foods ingredient side to come and understand that we also can be players and partners with them to grow this sector. So to scale up in terms of getting the equipment and the ingredients, and then to bring down the cost as well. Because when we try to shift this towards the food grade, we will bring down the cost, but we're not there yet. So that's some of the biggest challenges we're working with.
Yeah, maybe can I also add that
Sure.
we do have two different types of customers in that sense, because you're looking at what the one range is the extreme is the elderly population, the vulnerable ones. There's a masses of them that's in a nursing home or living alone at home, that's frail and old and in hospital, versus the ones that is affordable, that is rich and able to, well, maybe not rich, well-to-do enough to afford the higher-end personalized nutrition, to look at enjoyment of life. So I think there's two extreme ends of feeding the ones that's at the risk of malnutrition, vulnerable ones, as well as the ones that's having an enjoyment of life. Yeah. So there's two different tangents that we have to look at, and 3D food printing can actually meet those two different areas.
Yeah. Also, Gladys, I was wondering, like, are you really trying to imitate food, like as close as possible? Is that your goal? Or are you just trying to get it to go away from this mushy kind of everything is mashed potatoes kind of phase?
No. It has to be a mushy mashed potato face that is actually that the person can actually swallow safely. So I'm not having anything that's hard. It has to be pureed. So we're looking at the visual consistency of it. So it's something that's visual and it's actually a consistent production. So if you look at, for example, at the moment, we do have different nursing homes, that's different cooks, and different hospitals that's having different recipes, and it's inconsistent on how much water they put in order to make the puree blobs spoonable to actually put into your mouth. Right? But if let's say we have recipes that's consistent, 3D printing has got consistency of printing. It removes the manpower that you can just put electronically AI into it. And so everything is printed consistently, that I am assured as a healthcare provider that whatever I get the machine to print is exactly what is going to be fed to the patient. And that the patient will be confident of opening their mouth because they see the food as reality, that it looks good, to open your mouth, to put the food into your mouth and eat it and swallow it. And so I get that nutrition in. Whereas at the moment, there's a lot of variations where the vulnerables and the aging population, they are at home, then, because the food is just all brown, that looks like just brown mesh all mixed up together, they just don't eat it. They don't eat it, they get malnutrition, they end up in hospital. We have a different whole ballgame of issues altogether.
Yeah. I wonder if like you have a lot of people that might be attracted to very unhealthy foods like candy and stuff like that. Would it be ethical would it be a good idea to just make food that really reminds us and things like, and is a lot like steak, for example, or lollipops and candy, but is actually kind of healthy for us?
Yes, if it is possible. There's no really specific good food and bad food. It is really a conjurance of what is in the whole diet throughout the whole day. So if we can different things that we can modify together. The beauty of 3D food printing is that it's precision, as well as you can really put an equation to it to be able to have different combination of nutrients to put into a product that is visually appealing.
Mm-hmm.
Yeah, so the challenge is to make it visually appealing.
Sorry.
Yes,
I was just going to say, our products they look like candy and they taste like candy, and we actually do supply them to dementia care homes in the United Kingdom with special blends that are actually very high water content. Because one of the things that we found was that dementia patients suffer from bladder infection quite regularly from severe dehydration. This is down to a variety of factors, including the fact that they forget that they haven't drank any water, and they're worried that they will spill the water because they're losing some of their coordination, et cetera, in certain phases of the disease. And the reason why it worked so well, and we tried multiple different things, was because this group of people, the age of these people was about 55, actually 65, actually in this one study and above. And in their past, gummy candy, or they called them fruit pate, at least in the UK, was something very common to have on your coffee table to give to friends when they came over. And so you would pass it around and people were excited. They wanted to have more than one. Can I have more than one, et cetera? And it was exactly what you said. Is it unethical? No, I don't think so at all. It's just to get the nutrition into the diet any way you can. These were fortified with vitamins, totally sugar-free, but they felt really excited to eat them. So that's a win-win, right? I think.
Yes, exactly. Yeah.
Yeah.
So what we want to do is to really print things that people are willing to eat. You know, it has to be eaten. So so visually it helps to recognize, and so all the food technologies that make it taste good, so looks good, tastes good, swallow it safely.
Yeah.
Okay. And Dr. Ling, I was just wondering, like, a little bit, like, so when you're doing a startup, you guys are developing a technology. I think Melissa's really focused on being the end product and also doing production. Have you guys thought of, because there's different routes go to market that you could be doing. There's different routes to market. You could make this as a product. You could sell the technology to a food company. You could be the brand and say, this is the new Impossible Burger, but for shrimp. Are you guys figuring out those kind of things yet? Do you figure out where you want to be in the market, or?
I can start. For us, we're looking to produce our own crustacean products to go to the market, starting with restaurants and then in a few years' time into groceries. But our focus is the Asia Pacific market. It's going to be difficult for a single startup to kind of expand to be all over the world. So outside of the areas we're looking to target, we look forward to license our technology and share how this can be done by other partners who are interested in, whether be crustacean seafood farmers or other food companies or other cell-based companies who want to branch out into the crustacean side as well. So that's how we foresee we grow the company.
Okay. That's an interesting way to put it. To see it, that's a very kind of like pharmaceutical kind of way to look at the food business, I think. And if you're like looking at this right now, like, is the Asian market open to this kind of things? Are you going to? Because I think it's always interesting because, like, the whole idea of lab meat, like, as a marketing person, that's not going to be great, right? Are you guys going to be like kind of slipping it in there that just like really going to be kind of like not mentioning the fact that this is 3D printed or made in a lab? Or do you think you should present it as a big feature? Like, oh my God, this is like a new thing. You should want to try this.
Yeah, I mean, I think Impossible, even though they're plant-based, did a really good launch and people are really into it. I mean, our focus will be mentioning that it's sustainable, it's health-friendly and animal-friendly. And I think it's important for novel technologies like ours to be upfront and let consumers know. It's a lot of consumer education, and what we've seen from surveys we've done locally in Singapore and also from other partners in India and China, that I would say around 60% of the people are interested in cell-based meats, willing to try. But at the end of the day, what they will be interested in is the taste and the cost of the product as well.
And Gladys, are you guys telling the patients that this is like a new 3D printed thing? Is that a part of this process?
Well, we have a research project proposal already to actually look at the acceptance of 3D printed meals for patients. But we also must remember to be sort of realistic that there are a lot of people out there, the laymen, who don't even know what is 3D printing, let alone 3D food printing. Yeah, but if you come from a sustainability, food security issue, there will be a lot of people that's why there's all these advocates on going to plant-based diet, because there's just not enough animal protein to go around. So if there's not enough animal protein, we have to resource to plant protein. Otherwise, it'll be insect protein. So if you're looking futuristically, it will happen one day. If we don't cut down on our meat intake now, real meat intake now, we may end up eating insect protein. And I cannot imagine people will accept eating crickets, and grasshoppers on its own. It has to be in a different form. And it won't be just like little slabs. It will have to be printed out so that people will want to and willing to eat it, and that it will taste like meat as a substitute. Yeah. So there is a lot of acceptance that we have to look into even from now. So it's really all parallel everything, because you have all the 3D food printing. It's not just the food ink and the machinery. You have to look at really all the food safety aspects that goes with it, regulations. You're looking at transportation. Do you re-thermalize the food, and storage wise, and how do you package it? So there is a lot of partners that can come to a picture, including all the computer, IT, AI specialists.
Thank you, Gladys. Thank you, Joris, and the panelists. Thank you so much. I've got to interrupt you at this point in time. I think I'm going to become a vegetarian. I need too much meat going around, and so let's see.
So that you won't eat insect protein, right?
No. I think I'm going to stay away from the insects for a while now. So, but as much as I wish that we have all the time in the world, but we have many engaging attendees here. I think you're talking about very, very exciting topic here, 3D printed food. So before that, I think a quick reminder that if you would like to watch the playback of this session or any other sessions that we have been broadcasting since yesterday, do check out the Learn tab on iTab Connected platform. And but right now, let's dive into some of the questions that you, the audience, have been posting to our distinguished panelists. And I'm going to pick up a couple of questions here, and I'm going to hand it back to Joris. So the first one is, do you think 3D printed food or cellular agriculture will reduce food waste? Why and how so? Maybe Kai, you want to take that first?
Sure, thanks, Mahendran. Interesting question, and that's something that we also think is a benefit of cellular agriculture and 3D printing. By producing only the parts of the food we eat, then we don't need to be, for example, with crustaceans, right? I mean, all of us are very familiar with the shells and the legs, but then we have to crack it, and we don't really eat those parts of the animal. So if we only produce the parts that we eat with cellular agriculture, then we reduce a lot of these waste that we will see from the production process. So I think that's one of the good benefits of 3D printing and cellular agriculture.
Yeah, so it's a follow-on question as well. I think I'll just quickly read this out. How are the 3D printed food and cellular agriculture being regulated? So in your countries, Melissa, in the UK as well. So, and in your opinion, do you think your government is supportive of such efforts? Melissa, do you want to take that?
Sure. So yeah, the UK actually is very supportive of all new research and development. We have one of the strongest support packages of any country on earth. We get back money every year for the money that we spend on, we get 1.5 pounds back for every pound we spend on research and development each year. And we also benefit from something called Patent Box, which is a reduction in corporation tax for the life of the business if you develop a patented technology. For 3D printing specifically, where I'm based in Birmingham, we have 5 universities with 3D printing degree programs, and the National Additive Manufacturing Institute is in Coventry, about 30 miles away. And anybody with any project can go and use a humongous number of different 3D printers, can go and take classes on 3D printing. And we also have something called STEAM School down the road, which is very similar on a smaller scale. So as far as 3D printing being supported or research and development around this area being supported by the UK, I think it's extremely strong. And as far as the UK population's readiness and acceptance of 3D printed food, so far, everything we see is very positive based on the growth and the consumer feedback we've seen on the Nourish product.
All right. And so another question that was asked by the audience is, like, we've talked about it a little bit for Shiok Meats, but maybe from some of the other guys, what would be the major bottlenecks for the commercialization of 3D printed food or cellular agriculture? So do you guys have ideas? Is it a regulatory bottleneck? Is it consumer acceptance? Is it scaling up for everyone? Is that the opinion? What do you guys think?
I think regulatory rules around compliance for hygiene are very strict, and a lot of people who develop 3D printers don't understand them. So they need to take extra advice and really do a lot of research to make sure they're not developing a concept which will never actually be able to produce a product which is safe. I've actually worked with huge multinationals that have done this, that have wasted over $10 million developing a 3D printer that makes a product that nobody can eat, which is crazy, right? So there's that. But I also think the scalability issue is actually only in our minds now. The old school 3D printers were very slow, making one thing at a time, very slow. Oh my God, it used to kill me when I was doing it in the very beginning. But we now have the ability to create technology where, I mean, our printers downstairs have 7 extruder heads and can produce 30 totally customized products in about 4 minutes. So scalability is not the issue. It's more around, can we make the product really market accepted, and can we make sure that we can maintain the kind of hygiene and compliance for food regulations globally to be able to bring it to market on a global scale?
I've got a question for Gladys here. It's a very informed question, by the way. I understand you worked in New Zealand for a period. Do you think there's a difference in how people look at nutritious food as a whole in Singapore and New Zealand?
Wow.
Yeah.
Can you repeat the question again?
Oh, yeah, sure. Do you think there's a difference in how people look at nutritious food as a whole in Singapore and New Zealand?
I don't think so. I think it's internationally they're all quite similar because Singapore is also a multicultural society, isn't it? So I think you're looking at dietetics or even the healthcare system, then the focus is literally the same because people are all the same. But you're looking at the supply of food, the kind of foods that's available, then that will be a difference because in New Zealand itself, people can produce their own food in their backyard. Whereas in Singapore, we don't. We have to buy. We rely on export, and we rely on export of import of food. So now we are all going to vertical planting, planting rooftop gardening, but it will still be very small scale. So we have this in Singapore, this sustainability 30 by 30 rule of looking at how we can be more self-sufficient in Singapore to a certain extent. But New Zealand, they are more independent in their food supply compared to us. By looking at focus on nutrition, I don't think there's much of a difference. It's pretty quite same because Singaporeans are quite well read and New Zealanders are pretty intrinsically healthy because they have the luxury of the land and fresh air.
But they don't know. But they don't even realize it. Yeah. And do you?
That's right.
Yeah.
Do you think that so this is interesting from a Singaporean perspective? I mean, because it seems like it's you could do indoor farming and then you could then 3D print the food. You'd have less waste. We waste about 40% of our food going from farm to table, and then a 40% we throw away in the house. Do you think it could make a country as small and as compact and as densely populated as Singapore? Could it help make you guys more food secure or food independent? Is that something you could look at?
Yes, definitely there is. We have agencies that's looking to that now to really, because we're a small country, so we can act fast and do things in quite a controlled or supportive way that can make things happen. So hopefully it is in the runway to actually have looking at sustainability and rooftop gardening and looking at technology to reduce waste, minimize waste, and recycle waste and feed everybody, and it's all win-win situations for all.
Yeah. Okay. And there's a question for Dr. Ling. So will Shiok Meats explore other forms of meat in the near future other than shrimp? So you've already talked about crustaceans.
So,
what are you looking at?
Yeah, we'll focus on shrimp, and then we're also working on crab and lobster at the moment, but mostly in the crustacean family for now, and that's our main focus for the company.
Okay.
Just one thing that came across my mind too, in terms of shellfish, the beauty of it, we can actually print the shellfish and seafood. So those people who are allergic to certain proteins in the shellfish or seafood, they may end up being able to eat it because it's 3D printed and you can really isolate the cells and remove the allergens, isn't it? I mean, that's really futuristic thinking, but promising.
Yeah. I can't believe
That's
it's
a great
not peanut
idea.
butter.
That's a wonderful idea.
I think
I love
shellfish allergies is huge, but I would say from what we've looked into, because that's a huge concern for most, actually a lot of people of interest, but a lot of the allergens are actually muscle proteins. So unless we genetically modify and remove these proteins, the allergens will still be there. There are other people who are allergic to other environment conditions which the shellfish are grown into. These people often have later onset of the allergy. So those will likely be more the candidates who will not be allergic to 3D printed or cell-based shellfish. But otherwise, it will be a bit difficult just from the time being. But that really opens up the possibility in the future.
Oh, that's interesting. And just another interesting question, I think, is like, this is our last question, by the way, but you guys can all have a stab at it because I think it's important. You can kind of redress the balance a little bit. Is there a myth or a misconception that one has about cellular agriculture or 3D printed food that you would like to debunk and re-highlight? So is there some kind of misinformation or misconception that you guys will think is something we need to, you guys can address right now?
I think a lot of people think that 3D food printing is really printing things at spaceship, space NASA type of meals that is not real food. So we have to convince people that it's real food. The ink is real ink. It may have some kind of a thickening agent in it to the gum to actually gum it up together. But if it's odorless, if it's tasteless and has the same mouthfeel, then it should be okay. But it's just that people just think that you're printing plastic and you want me to eat plastic, rather than real actual food that is pureed, that's minced up.
And Melissa, what do you think?
I think from my side, thank you. I think from my side, one of the things that maybe kind of reverse answer to this question is the way that people think 3D printing it adds value to everything, which is absolutely not true. If you remember, there was tons of comparisons to 3D printing to this idea of Spock having this materializer where he would basically press a button and a cup of coffee would come out of the machine, one layer at a time. 3D printing total liquid is totally pointless. You would never use a 3D printer to print liquid. You would just use a dispensing device. And I think that's one of the things we find. 3D printing is absolutely amazing, but it's such a new technology still. We're still working out the best ways that it can add value. And we're very strict here about new development projects. And if it's not adding value, we just don't do it. And I think that's something that we should all be very, very much aware of.
Yeah, good point. And you, Dr. Ling, what do you think?
Yeah, I mean, similar to what Gladys is saying is I want to kind of highlight that a lot of the foods we actually eat, unless you go straight to the farm or the ocean to catch it, they're all processed. They have been actually mixed with some preservatives or other things in a lab. It was also lab made in a sense, but I think a lot of people associate cellular agriculture as very Frankenstein, lab grown, as very strange, but actually a lot of the modern foods we eat were all, they were all tailored and they were tested in a lab setting, but that's not something strange. We've all eaten it, and some of it is for our benefit, some not. And I think just to highlight that, this is kind of a important way for us to progress in the future, for us to have more options to deal with our increasing population. We need to innovate. We need to deal with our aging population and our increasing need for food. So I think these 3D printing and cellular agriculture are very important things that will become probably just day-to-day in the future. People are not going to find it strange or surprised about it.
Okay. Well, thank you so much, guys. I think it's a wonderful roundup, and I learned a lot. So I hope the people watching for their homes or their offices and learned a lot as well. And I think it's time for us to switch back to Mahan, who's going to close off the session. And I'd like to thank you guys very much for participating and teaching us so much.
Thank you.
Joris, Kai, Gladys, and Melissa, thank you so much for your insights and time being with us today. It has been 2 days of information-packed, inspiring content that all of our 13 speakers and moderators have delivered. It's my utmost pleasure to have all of you with us at the NAMIC Global AM Summit 2020. We hope everyone had a fruitful experience over the past 2 days discovering 3D printing and its applications. On behalf of the entire team that has brought to you this summit, I thank everyone for taking your time to join us in NAMIC's first ever virtual summit. Once again, special thanks must go to our wonderful speakers and moderators who had taken their time for this summit. This is not a goodbye, but a definite see you again soon. Till then, take care and follow us at namic.sg/events/GAMS2020 to stay connected, and do stay tuned for more at the GAMS ITAB Connected platform for the global insights. This is Mahendran Reddy wishing one and all a wonderful rest of the day ahead. Bye for now.